adoption will scale, credibility and compliance follows thereafter. So on behalf of CDOT and Vodafone Idea, I would like to invite all of you to our lab. Please, we would really like to work with you. This is not any cost for you. It is an entire investment from our side. And from our organization side, it's been a very, very big investment over a period of 3-year journey. We are already committed to it. And in Q4, we are launching another program to invite almost 1,000 startups. There'll be some bit of co-funding also in that. I think take advantage of that, and it's in Bombay. And our journey cannot be complete without great colleagues, great partners. And I think so that is where I would like to take a moment to showcase some of them with whom we have developed a lot of joint learnings. And on that note, thank you very much for this opportunity, Dr. Upadhyay, for inviting me. Thank you, everybody, for your time. Thank you.
Thank you very much, sir. And all the more because you adhere to the timeline given. Thank you. Our next speaker will be joining us remotely, Mr. Roland Heckwartner, Deutsche Telekom AG Mobile International Austria, ETSI, One M2M Technical Plenary Chair. He'll be speaking on One M2M releases, what's new. So let's welcome Mr. Roland Heckwartner.
Been invited by CDOT to this global conference on IoT M2M growth of the IoT M2M ecosystem through standardized implementations. In my talk, the One M2M release, what's new, I'll summarize the main characteristics of One M2M, the evolution of features in the series of releases, highlighting Release 4 and closing with an outlook on Release 5. This is not intended to be an exhaustive overview at all. At the end, I add some slides of the present with links to more detailed information. My name is Roland Heckwartner. I am chair of the One M2M Technical Plenary and represent Deutsche Telekom in One M2M. One M2M is a global organization, a partnership project of Good afternoon. I'm very pleased and honored having been invited by CDOT to this global conference on IoT M2M growth of the IoT M2M ecosystem through standardized implementations. In my talk, the One M2M release, what's new, I'll summarize the main characteristics of One M2M, the evolution of features in the series of releases, highlighting Release 4 and closing with an outlook on Release 5. This is not intended to be an exhaustive overview at all. At the end, I add some slides of the present with links to more detailed information. My name is Roland Heckwartner. I am chair of the One M2M Technical Plenary and represent Deutsche Telekom in One M2M. One M2M is a global organization, a partnership project of the regional SDOs in North America, Europe, India, China, Japan, and Korea. Their members, more than 200 organizations, have been taking part in the development of the One M2M specifications. It was founded in 2012. This year, we celebrated the 10 years anniversary. Initially, and still today, the main objective is to join forces towards a global standard to reduce fragmentation and reuse existing technologies as much as possible. Beside the founding partners, additional partners joined. Global Platform as an actual partner, and IoT SG20 transposed the 1M2M Release 2 in their Y4500 series. The key events timeline highlights the history of milestones achieved and events held. The red colored dots show the release milestones. The blue dots, the interoperability events that took place. The last was held last week. The dots in green depict the hackathon events, and below the timeline, you see the industry events, regional outreach events, which were co-located with 1M2M TP meetings. And additionally, the publication of collateral material, here for instance, the sustainability white paper, which was released only recently. Last but not least, you can see the milestones of the certification program, started by TTA in 2017 and put on a global level to GCF in 2019. What you can take away from the timeline, and I'd like to emphasize that, is that 1M2M defines specification and makes standards. It has a complementing interoperability testing and a certification program. In summary, it shows also that 1M2M is mature and deployed technology. 1M2M breaks down the silos. This slide depicts the main situation at the starting point in 2012 and to a large extent reflects as well the current situation of IoT deployments, where we experience a highly fragmented market with vendor-specific applications where each silo contains its own technology, its own protocol stack, without interoperability across the specific applications and data, resulting in many hundreds of platforms and incompatible tools, reinventing the wheel. The same services are developed again and again. From the very beginning, the goals of 1M2M were to simplify the environment, remove unnecessary duplicated solutions, and achieve economy of scale, and at the same time preserve the necessary specialized solution by defining an end-to-end service layer framework, the common service capability layer, abstracted from the connectivity, hence enabling interoperability at the level of data and control exchanges via uniform APIs, support seamless interaction between heterogeneous applications and devices, and simplifying the work for developers who can use the standardized tools to build and support IoT systems as required by the use cases and are adjustable for various deployments, which will eventually reduce the platform development and integration costs, enlarge the market, and enable real competition on services. This slide shows a high-level overview of the defined common services entity, which consists of service functions, so-called CSFs, that are commonly needed for applications across so-called vertical domains. They provide a toolkit which can be used as required by specific deployment scenarios. This common need has been expressed in different use cases contributed to 1M2M, and the derived requirements are contained in the requirement specifications and further detailed in the other technical specifications. And as you can see, those common service functions comprise a rich set of functionalities. Dependent on the deployment scenario, only the related service functions need to be implemented, however, within the different CSEs. CSEs on infrastructure, on middle nodes or gateways or devices. Of course, the deployed service functions can be enhanced and new ones added. This can be done over time as required by new use cases. So you can start small and simple and enhance later to provide more enhanced and rich features. Here you can see the evolution of features per one M2M release. It all began with a basic set of functionality in release 1 on the far left and steadily grow based on market demands to release 4 and release 5. An important feature of one M2M is that it is designed to interwork with or integrate with other technologies, standardized or even proprietary ones, without awareness of the applications on top. When properly interworked, all devices, sensors, and related data can be accessed by the applications on top of one M2M. Release 4 is introducing new features, to name a few like semantic reasoning, time management, enhanced support of fog edge computing by enabling software campaigning and resource synchronization, enhanced 3GPP interworking by introducing session QoS and congestion monitoring. In addition, a public warning service enablement and security enhancements are contained in Release 4. All that across multiple supported domain models as in the Smart Device Template 4.0. The Smart Device Template is a template method that is used to model the capabilities, information models, and semantics of connected devices. It's independent of underlying IoT domains, network technologies, and enables uniform APIs for applications. The Release 4 deliverables are listed here. Beginning of December, at the 1M2M TP57 meeting, a major milestone was achieved. The Release 4 was ratified. We agreed the list of specifications for publication by the organizational partners. This is meant by ratification. These listed specification, 23 as you can see here, and additional 7 technical reports are contained in the Release 4. What's next? And this is where I'd like to close this introduction to what's new in 1M2M. It's an overview of the current ongoing development of Release 5. We are working on use cases, studies, and requirement definitions targeting Release 5 and first enhancements also to stage 2 related specifications, functional architectures or protocols. The Release 5 work items are listed here, and I'd like to highlight a few. The AI enablement is a work that is analyzing within a technical report the existing AI ML technologies that can be resourced into the 1M2M architecture. Based on the result of this technical report, it will identify potential requirements and key features to enable AI ML in the 1M2M system. Then you see information model enhancements. I discussed that briefly. What is the Smart Device Template? So these enhancements to that information models are contributed within the work item. Then the support of data protection regulations. You see also in Release 4 a TR, and the TR of Release 4 describes the state-of-the-art privacy-related regulations and their features. And what's also done in this TR is a gap analysis to find out what features are supported and not supported by the current one M2M system. And based on the result of this technical report, it will identify possible enhancements of features to support data protection regulations, which the next one M2M releases, in this case release 5 and following, could support. Support of data license management, which is important to automate the access and exchange of data and to comply to the licenses applied to the data, and to do that in an automated way. So it's similar as before. In a study, it will be described what's there and which identifiers and which licenses, and then it will be derived what technical solutions might be required to be added to the 1M2M service layer. The same for smart city and enterprise domain enablement enhancements, and also enablement of IoT in the metaverse, a very new work item, where we had also a workshop related to this work item at the last TP meeting on November 29. This workshop was open to all interested parties, and the objectives of the workshop, and at the same time the objectives of the current work in this work item, are to discuss the scope and definition of metaverse and metaverse IoT, to identify links between metaverse and IoT, and discuss related use cases and scenarios, as well as to improve interoperability with other paradigms. These were discussed and will be discussed by the leading questions, that what is metaverse IoT, what are or is the key service technology of metaverse IoT, and how do we handle the metaverse services in 1M2M world. So if you would like to take part, please attend one of the next 1M2M RDM working group meetings or some of the open workshop meetings. Advanced semantic discovery and additional interworkings are part of release 5, and last but not least, effective IoT communication to protect 3GPP networks is continued also for release 5, taking into account enhancements of the underlying 3GPP network capabilities. And the next TP meeting in February it will be held in India, and here we will discuss the release 5 timeline. It will be revised and further detailed. Current expectation is that the release 5 will be finalized in 2024. Before ending, I'd like to inform you that the first set of the 1M2M tutorials using Jupyter notebooks are now online, and there are more to come soon. And by following the links, the tools, as well as more detailed information will be provided, so you can get some hands-on experience in 1M2M. For more information, please visit the 1M2M website, which provides a lot of information, and please do not hesitate to contact me for further questions you might have. This ends my talk. Many thanks to you and to CDOT for inviting me. It was a pleasure being here today, and have a further interesting conference. Goodbye.
Thank you very much, Mr. Roland. Our next speaker is also joining us remotely. Let's welcome Ms. Rana Kamil, IoT WP1 Vice Chair, and she'll be talking about 1M2M IoT collaboration.
Madam, am I audible to you?
Hello, hello. Hi. Good morning.
You may, yeah, you are audible. Good morning. You may share your screen.
Yes, thank you so much. Sorry, I've been having some technical issues. I think it's okay now. Please let me know when you can see my screen.
Yes, ma'am, it's visible. Thank you.
Thank you so much. So good morning to everyone. Thank you very much for inviting me. I really appreciate being a part of this event. It's always a pleasure to talk to CDOT and TSDSI. I'm very happy to be here today. Thank you. So today we'll be talking about M2M IoT collaboration. I'm sorry, may I just stop the camera for a short while because I believe it's affecting the connection a little bit. I will switch it back on once I finish the presentation. Thank you very much. So, okay, is that okay? Okay, thank you very much. So the collaboration process between M2M and the IoT SG20, Internet of Things, IoT and Smart Cities and Communities, started in 2018. The IoT SG20 initially made 28 comments or recommendations to apply throughout the document, which is TS0003, our security document. M2M had many meetings with the IoT and thorough technical discussions with experts from both sides. The changes agreed were incorporated throughout the document, and some were agreed to remain unchanged due to some difference in procedures, but we have agreed about all the comments. So here we have a timeline about the IoT collaboration. The last IoT SG20 meeting was a face-to-face meeting that took place in Geneva between the 18th and the 28th of July. There were 3 official meetings between the IoT and M2M. Another 2 were added later to the agenda. There were also 3 unofficial or offline meetings to discuss some particular aspects with interested member states. One of them lasted for 5 hours. We had very long meetings. So experts from both sides agreed on how to process the remaining recommendations, and TS0003 document was finalized. The document has been agreed by Q6, approved by Working Party 2, then by SG20 plenary. We have a few slides that explain the structure of SG20 later to explain what are Q6, WP2, and the SG20 plenary. The next meeting will take place in Geneva between the 30th of January and the 10th of February 2023. So the ITU has 193 member states, 900 plus companies, universities, and international and regional organizations, and it is made up of 3 sectors: standardization, development, and radio communication. So the standardization part is the ITUT. This is the sector that we work closely with. The ITUT promotes enabling technical policy and regulatory frameworks to boost ICT development. It's a platform for governments and private sectors to coordinate development of telecommunication networks and services that connect the world. Second part is radio communication ITUR. It coordinates the shared global use of radio spectrum and the geostationary satellite orbit. Then there is ITUD, which works to improve telecommunication infrastructure in the developing world. So the ITUT strategic goals, it is driven to remain the preeminent worldwide telecommunication standards body. That's what the ITUT aims. It develops interoperable, non-discriminatory international standards. It needs to be fair for all member states. It assists in bridging the standardization gap between developed and developing countries. So every country has equal rights to make contributions and to agree or disagree about certain proposals. It also aims to extend and facilitate international cooperation among international, regional, and national standards bodies. So we have the structure of the ITUT here. There is the TSAG, and then there are study groups. So study groups are made up of working parties. For example, the TSAG stands for Telecommunications Standardization Advisory Group here. And then we have the study groups. Each study group is made of working parties, and working parties are made of questions. This is a slide about different groups in the ITUT. We have SG2, 3, 5, 9, 11, 12. We have up to SG20, and this is the one that we collaborate with. It is IoT, smart cities and communities. So this slide has the names of other study groups and what they do. Sometimes there are also liaison statements between SG20 and other study groups to update one another on matters that are equally interesting for both groups. So these groups sometimes also work together. Now, when we look at the group structure, we have study group chairman and vice chairman. Then we have the working party chairman and vice chairman. We have management team, a leadership team, rapporteurs, associate rapporteurs, editors, liaison rapporteurs, and delegates. Each study group has its own area of responsibility, leadership team, work program, including authority to initiate, develop, and propose approval of deliverables. The study group mandate is defined by WTSA every 4 years, and it's implemented via questions, like question 6 that we were working closely with. And it may be refined during the study period between WTSAs. So there are now the decision-making process. There are types of ITUT decision-making process. There is soft and hard criteria. So as we mentioned earlier, in order for a document to be approved, it needs to be first agreed by the question in which it's being discussed, like we did with question 6, then agreed by the working party, then agreed by the SA plenary. We have done all of that. Then it either has to go through TAP or AAP, so a traditional approval process or an alternative approval process. So the traditional approval process TAP is for recommendations having policy or regulatory implications that member states have a final decision. The alternative approval process is for all recommendations and that have agreement that no member states don't agree about. TAP is typically longer, and it is the route taken when more than one member state is not fully in agreement with the approval. Often this happens because sometimes different member states have some concerns about using examples of certain protocols that they do, or examples of things that are happening in other member states that they don't want it mentioned. So often the member states have disagreements during these meetings, and then there needs to be offline meeting schedules or further sessions scheduled to resolve these concerns. So as mentioned, the ITUT is a United Nations specialized agency, so only member states have the right to vote. However, agreement of sector members is important for approval of technical recommendations. These rules allow for a public and private partnership while respecting the member states' rights. So most decisions, but not all of them, are made on the basis of consensus. Now, these are two diagrams explaining the TAP process and the AAP process. So in summary, just for the sake of time, in summary, the TAP is the longer one, which happens when there is disagreement. And it happens with most documents before being transposed, because there usually are disagreement. It's very hard in any UN body to have unanimous agreement from all member states. Then we have AAP here, which is shorter. So now we are looking at some ITUT procedures. So inside the ITUT, there are some procedures that all documents that need to be transposed have to follow. For example, A.5, which is a procedure for including all references in a specific way that is used by the ITUT. It needs to be uploaded on their website. It needs to be written in a specific format. And if not every single reference is written in that way, then the document is automatically rejected. So we had to go through this process. There is 8.8, which is an alternative approval process for new and revised ITUT documents. So if a document is revised, it can go through the 8.8. These are just examples of the processes. And then we have the 8.25 recommendation, which is one of the challenging process because it's a generic procedure for incorporating text between ITUT and other organizations. So when the ITUT comes to transpose documents worked on by other organizations, every member of the standards body or the organization needs to go through this 8.25 procedure. So, oh, there's a tomb. Yes. So here we have the a slide about the challenges that that we have gone through. So when we after we almost got the document agreed, we were challenged that one of the processes that we were told that the collaboration needs to stop by one of the opposing member states because TSDSI has recently joined 1M2M and it still didn't go through the process. So we challenged this and we said that TSDSI heavily inputs into 3GPP, which regularly inputs into the ITUR, which is also a part of the ITU. We contacted TSDSI and they kindly sent this this line that solved all the problems, saying copyright, software copyright and trademark guidelines will be fully compatible with ITUT's current policies and guidelines. The same. And we used will be because some of them, of the software and the documents were still being written. And I would like to take this opportunity to thank TSDSI for the great cooperation. I remember we were having calls at midnight in India, at midnight in Geneva, going through this, and we needed to do it very quickly, and TSDSI has done that. So thank you very much. Again, I would like to thank TSDSI for their cooperation with us. Now TSDSI has gone through the process, which is amazing. So the summary is, where are we now? We got the document approved by Q6. This took several years because there were always some comments and now there are liaison statements on how to develop a quicker process to do the transposition in a quicker way. But we have gone through all the conversations and we got agreement. Then it got approved by WP2, Working Party 2. Then it got approved by the SG20. A copy of the document that has been finalized has been sent for determination, was published on the ITUT website on the 14th of September. So the document is being finalized. Currently, the document is going through TAP, the traditional approval process, which will hopefully be final. This is the final stage, it's just the paperwork and the final stages. It will be finalized by the next meeting. Once it's completed, it will be officially and the document will be completely and officially transposed by the ITUT. This will hopefully happen in the next meeting in 2023, but we are done with all the work, all the discussions, all the processes, everything. It's just the very final stage now, and it's something we are very proud of. The UK has presented a liaison statement suggesting developing a better mechanism for collaboration and a quicker process, and the ITUT agreed, even people from the ITUT management agreed that we need to develop a very quick process, and they are showing willingness to collaborate with 1M2M to transpose future releases and collaborate better. Now, this slide is about benefits between of the collaboration between 1M2M and the ITUT. So the ITUT recommendations are recognized worldwide since the ITU is a part of the UN. 1M2M and ETSI are very popular in Europe and also internationally, but some countries, North Africa and South America, generally just refer to I2T standards. Collaboration with I2T gives 1M2M also more visibility and recognition internationally. And the more we collaborate with international organizations, the more we benefit from the expertise of international experts, and the easier it becomes for 1M2M standards to be implemented worldwide. Thank you very much for your time. I'm not sure if my camera is still working or not, but thank you so much for your time, and I'm very pleased to be a part of the event today. And if you have any questions about the collaboration, about the I2T, or attending the meetings, anything about the meetings, please feel free to reach out by email. Thank you once again.
We'll be having the Q&A session after the entire session.
Perfect. Thank you very much,
very much.
Pamela.
Thank you. Next speaker हमारे हैं Mr. Manikandan K, Joint Director, BIS. He'll be speaking on IoT standardization in BIS. Please welcome him.
Good afternoon, everyone. So let me thank CDOT and TSDSI for inviting me to speak on IoT standardization efforts in BIS. So my presentation will be quick. I have few slides. So I'll be talking about the standardization happening in BIS in the area of IoT and related technologies. Just before come to the main point, I have two slides on BIS just for the information of all the participants here. I hope most of you, all of you know BIS is the national standards body. So in addition to developing standards, we have some other few other core activities, like we are also into conformity assessment. We have popular ISI mark, I hope all of you know, product certification. And we also have a registration scheme for electronics and IT products, and a gold hallmarking, and also management system certification. And we also have laboratories for testing, checking compliance with the conformity with the Indian standards. And we have a training institute in Noida. So this is a quick summary of where we are in terms of developing national standards. We develop national standards through 14 division council, which covers the entire whole sectors of economy and technology. And we develop standards through 390 plus technical committees, which we call sectional committees. And there are several subcommittees, panel, working groups under each of the sectional committees. And we have a pool of 10,000 plus experts participating from different stakeholder category group, which is from government. There are participation from academia, industry, so and so. And we have published more than 20,000 standards so far. Now coming to the IoT standardization in BIS. So we have a technical committee, which we call LITD 27, Internet of Things and Related Technology Sectional Committee. The scope of the committee is here to develop standards in the field of IoT and related technologies, including sensor networks. There is a recent update here, although this is the official scope. The committee also covers digital twin within the scope of this committee. And another mandate given to this sectional committee is to mirror the standardization work happening at international level, especially in ISO IEC JTC1, SC41, Internet of Things and Digital Twin. And it has couple of working groups, as you can see in the slide. One working group on IoT architecture, working group on IoT interoperability, then IoT applications, working group on digital twin and underwater IoT and digital twin applications. So far, we in BIS we initiated IoT standardization in 2015 by constituting a panel, and over a period of time that transformed into a full-fledged technical committee that can develop standards. So far it developed only 2 standards. One is on information technology, IoT use cases, and another series of standards on Open Connectivity Foundation, OCF foundations, are under development. It's a series of 18 standards. It is presently in the wide circulation stage, so maybe in another 4 or 5 months, those standards will be released. And another standard about which I'll be talking a bit more detail is IS 18004 systems reference architecture. So, which can be a level playing field for all the players in, or all the organizations, project implementers, SIs or MSIs. So that was the idea, where we initiated development of a series of standards for the digital infrastructure, and one of the master document, which is Smart Cities ICT reference architecture, identifies this M2M as one of the core components of the architecture, and that's the very reason why we developed this standard. And thanks to Arindamji, who was leading this activity and who contributed a lot in developing this standard. And the scope of the standard is it describes IoT reference architecture that comprises a conceptual model, a reference model, and deployment views. While developing this standard, of course, many organizations, many standard developing organization, everyone is developing standard on literally everything. You take smart city, IoT, AI, everyone is jumping into all this area. So we thought, let us not create a new standard. So in a way, we identified all the potential standards that can help our smart cities, and we in a way we can say created a bouquet of standard which can be referred for any IoT system developer. So this standard in the development, we took reference from ISO standard, which is ISO IEC 30141 IoT reference architecture, and another document is ITU standard Y.3056. And then there are several TEC, basically 1M2M standards, which is adopted by TEC. So we referred these 3 standards. So here is overview of this standard, the architecture description. So it gives a conceptual model, and it gives 2 reference model, which is derived from the conceptual model. One is domain-based and entity-based reference models. And from the reference model, we derive the reference architecture. And again, it is IoT service layer architecture and functional architecture. The conceptual model is derived from the ISO standard, and the functional architecture is derived from the ITU standard, and the service layer architecture is from 1M2M specifications. So here is the technical details, the conceptual model taken from ISO standard, and this is the service layer architecture and a functional architecture. So these are the 1M2M standards. These are the standards, a list of standards referred in the development of reference architecture. And as you can see, there are several 1M2M specification we referred in this document, in this standard. International level, BIS actively participate in the standard development process of one of the technical committees, which is a joint technical committee of ISO and IEC. Which is known as JTC1 SE41 on IoT and digital twin. So we actively contribute by nominating domain experts in various working groups under this technical committee. So at present, we are very actively contributing to some of the projects which are listed here. One project on underwater network management system interworking. This project is actually led by India, and the other projects, autonomous the status of self-quarantine through IoT data interface, and addressing interoperability between IPv6-based network and underwater sensor network. These three projects our Indian experts are actively contributing.
Yeah, good afternoon, ladies and gentlemen. I think we are already running late, and I'm standing between the lunch and the session. Because a few of my fellow speakers have already spoken about it. I will just like to talk about why we are doing what we are doing. That is why we invested so much into standardization and why we delved into one M2M, which are far minuscule in size as compared to us, almost negligible amount of diversity in those countries as compared to us, and almost negligible amount of challenges that we have in our country. Thanks to all my fellow speakers who are also partnering with us in this endeavor of standardization, in this endeavor of harmonizing our individual efforts into a collective effort. This particular slide only talks about the volume that is going to be kind of a manifestation of the efforts that we put in towards IoT, because more and more applications mean more and more customers getting interested into IoT-centric things, and that will culminate into more devices. So it's a circle. So we have to create those kind of applications which will encourage people to embrace this ecosystem, and thereby this particular ecosystem will grow, and the number of devices that you are seeing getting projected will become even more in numbers. More in numbers means challenges will be more. So the mitigation strategies have to be there from the word go. So if you are looking for a very large landscape of IoT ecosystem, we need to roll up our sleeves and get into standardization. And that's what we thought when we jumped into this particular area of IoT M2M in 2014, and not delved into the application domain, which was the most enticing low-hanging fruit at that point in time. We took up the challenge of getting into creating a standards compliant platform, and then create an ecosystem where people like you, the partners like you, will create solutions, engage with us, and will give a wholesome solution which is standardized to our customers. Just one point regarding India, that why it is important. Just see the growth that we have had. The 2 years of pandemic had kind of seen, we witnessed that the connected world can help us mitigate the challenges, even the likes of the pandemic. And after that, we have seen the modules, IoT modules have had an increase of 264% growth. This is phenomenal, but this is only the tip of the iceberg. There's more to come. Now, these have already been spoken by, I think in the morning by Shikha and our director Shikha, and also by Roland. So typical IoT ecosystem that we have always witnessed have these siloed ecosystem wherein we put some devices, sensors, using some kind of a network gateway, reach out to application in a very, very closed loop manner. Many applications like these you have witnessed and you continue to witness, because this particular proliferation is continuing. Even we are talking about standardization, people are making these kind of applications, and thereby the consumers are losing, because consumers do not have a vision to peep inside what lies beneath and what is there tomorrow. So what we thought, that instead of this ecosystem wherein everything is fragmented, everything is very siloed, everything is very verticalized, we get into something which is horizontal. So that is which gave the genesis of these are the different types of implementations that have happened, different use cases. And I'll not talk about these, but jump onto this. This is what we have aimed at, to create an ecosystem of horizontal framework. And that is what is the basis, the core of 1M2M. 1M2M talks about horizontalizing this ecosystem, wherein all the necessary ingredients of all IoT applications are put into a common service layer and provide as a service to the endpoints. What it brings to the table for everyone, besides all those 3 points that Amit spoke about in his presentation, it provides faster kind of rollout of applications, faster rollout of services, bigger scale out. The scaling is huge. Apart from that, it also gives the option of sharing of data, sharing of resources, sharing the hardware that you are using between two diverged applications. One example is that your connected car, which is now being controlled by the manufacturer, because they are the ones who are providing solutions. So you have only one solution at a time on your card. Despite the fact that the OBD port is a standardized port, still, if you have a Honda, it will be a Honda Connect. If you have a Maruti, you have a Maruti Connect. So sharing of data is not there. Think about it, where you have a standardized application on a car, and all these people are able to share the information in a very secured manner. And you, being the owner of the car, is the controlling authority of deciding as to who is going to share the information with. You want to share the information with. So 1M2M breaks down the silos. This slide you already saw. Roland also showed this. And what it gives us is that instead of each domain, each vertical creating the entirety of the stack from bottom to top, we are talking about this everything horizontal, because your connectivity, your application, data storage, data analytics, data presentation are all business use cases. What we bring to the table is the IoT service enablement function, which are basically the service layer. And what make it the service layer are the common service functions, which I'm going to present. So for a developer, it is just like an analogy is drawn, just like the Android of the mobile world, which is there for everybody to make use of because of the APIs, because of the ease of utilizing those APIs to develop applications. The same way, the common service functions are the toolkit which the developers use to carve out applications in a faster manner. And then the same things can be replicated across multiple domains and multiple service providers so that they can create their own business cases. So it doesn't peep into the business use case. It doesn't peep into the data part of it. It only is an enablement platform for people to develop applications in an open and standardized manner. So without further ado, I'll move. So the field devices and the IoT infrastructure domain, this presentation will be available for you. So what I'm talking about is the feature, the IoT service layer. It is there in the field domain devices also. It is there on the infrastructure domain devices also, in different magnitude, in different scales, and different flavors, which can be used. So what it also does is that it abstracts technologies. So for a street light solution provider, smart street light solution provider, the street lights come from any vendor. This had been the most troubling thing in the smart city ecosystem that have been rolled out in the country, that people are reeling under that vendor lock-in scenario, wherein one particular vendor who had supplied some material earlier does not exist or ceases to exist. Now that particular use case is stalled. So this abstraction provides the opportunity for the stakeholders, for the consumer of this particular application, to be not tied to one vendor. So a street light is a street light for a one M2M ecosystem, be it a Philips, be it a Marvin, be it anybody. So if it is like that, your application can continue to work if it is standardized with any of the other street light vendor, if you are using things right, if you are designing the solution right. So the connectivity layer, the protocols that are used within that are all abstracted, and one M2M gives you a standardized interface to create your applications, develop your applications, and roll them out. So I was talking about the common service functions. So these are the common service functions which can be seen as the toolkit for the developers to use it. So they are very robustly specified in the specifications of one M2M. People have painstakingly drafted them. They are under continuous revisions, modifications. Yeah, you have just heard Roland talking about it. We are going forward to release 5 now. Release 4 is going to come out, I think, in the next month. It has already been ratified. Only the editorial changes are being done, and it will be released very soon. And then we'll jump on to release 5, which will leapfrog from what it is and will leverage the upcoming networking technologies also. It has got very robust interworking also. The 3GPP interworking is a very strong interworking. Apart from 3GPP interworking, it has got so many other interworkings as well, wherein it is able to utilize the special features of a particular standard, which is a de facto standard like 3GPP, and to make use of those features to give better value propositions, like integration with NB-IoT, integration with a service capability exposure function of a 3GPP framework, so that those are the added benefits of using one M2M. Now let me tell you, no other standard in the world, no other standard exists which is as comprehensive as ONNET. That's altogether a different matter, but no other standard or no other platform exists in the world which has such a close integration with the 3GPP framework. The T8 interface of 3GPP interworks only with one M2M platform and no other platform in the world. So moving forward, the industry collaboration, it never took up everything to be done under the umbrella of one M2M. Whatever is the best practice of the world, it embraced that and created a comprehensive suite of specifications for 1M2M for the people to adopt and people to use. Those who are partnering with us, who have experienced how this works, now can vouch that this is very easy and this is the way things should be for the customers. So, I'm so sorry for this thing. So in a typical scenario of IoT deployment, because this was supposed to be told, because there will be multiple service providers of 1M2M based solutions. So only this frameworks allows you to have a coexistence of multiple service providers in the domain. There can be one Vodafone idea for a 1M2M compliant IoT platform. There can be their competitors also sitting alongside. And this is the only standard which will allow for a homogeneous access across various platforms together, because this has also been
So CSP allows any IoT application to discover and interact with any IoT device. And this is based on the access control policies, which are provided by the 1M2M standards. CCSP is the India's first indigenous standards-based IoT platform. This increases reusability of devices and data, because various applications can share their data, various devices, they are pushing the data into the CCSP, which can be transferred to various applications, bringing about innovative applications, thus reducing the cost of deployment and maintenance, because the number of devices which will be put will be reduced by the use of a standard-based IoT platform. Also, when you see that you have to deploy a similar solution into many locations or states, if the platform being deployed is following certain standard, then it becomes very much easier for the application provider to not to modify its application, because it will be using the standard-based APIs and it can communicate with any of the standard-based IoT platform. So if various cities of India are deploying 1M2M based IoT platform, then the ecosystem becomes very easy for the for the application providers. So 1M2M standard-based CCSP middleware is what is a CCSP. It enables standard-based M2M communication. CCSP caters to the common requirements of the M2M applications across various verticals and industries like transport, health, water, electricity, fire, etc. Because the common services have been taken out and it has been put as a common service functions in the service layer, and these are being offered by the IoT platform CCSP. It allows for interoperability by acting as a service between the data collection, acquisition, and the data consumer applications. The data collection devices can come from one party and the consumer applications can come from another party. And since standard is being followed, the implementation of the solution becomes much easier. So out of these 12 common service functions which were supported in release 3, the ones which have been marked as blue are the ones which are supported by CCSP as of now. And we are right now working towards release 4 features. So CCSP is compliant to release 3 specifications of 1M2M, and we are already supporting some of the advanced features of release 4. We are supporting 11 common service functions, and we are supporting PSK and certificate-based TLS security. RESTful resource-oriented APIs are there. XML and JSON data formats are supported. The common protocols used by IoT solutions, which are HTTP, QoAP, MQTT, all of these are supported. And we are supporting them in secure mode. And certain advanced functionalities are supported, which I'll be covering. So these are the advanced functionalities which we are supporting. Apart from the common service functions, the specification also specifies certain advanced functionalities as part of release 3, which have been put as common service functions as part of release 4. So if you have seen the Roland slide, there was semantics common service function, there was time management common service function. So earlier they were part of the release 3 as functionalities, but now they have been put as common service functions in release 4. So we are supporting service subscription management, semantics, time series, flexible containers concept, the 3GPP interworking and NB-IoT for non-IP data delivery for NB-IoT devices. We are supporting the T8 interface at the IoT platform CCSP, as well as we have our own SCEF implementation, which we have integrated with our 4G core. We are also supporting middle node and ASN configurations. The middle node is the gateway node, where we are supporting the CCA. We are providing CCSP for gateways. So organizations who have got IoT gateways, we have got the solution of MNCCSP, which can be ported onto their devices. The transaction management, request modes, various request modes are supported. We are supporting the announcement because there are various, the hierarchy of devices is supported by one M2M. Therefore, we support the resource announcement. The resources which are defined, the resources means the data points which are defined on a gateway, they can be announced onto the infrastructure node. So we also support field device configuration and device management using the typical TR069 and lightweight M2M protocols. As far as release 4 features, we are supporting the primitive profile, which enables the non-IP data delivery as it reduces the payload size of the transaction. We are also putting the service restrictions to see that whatever data points are defined, data is defined, how much is the time of that data, basically what is the life of that data. So if the data life is very old, we will be basically checks are there to offer service accordingly. And service subscription has been linked for various field nodes. So these are some of the advanced features of release 4, which we are supporting. So once you'll get into more of the 1M2M specifications, you'll know what exactly these features are, because it's a set of, if you see around 18 common service functions, it's very difficult to explain them in such a short period of time. But we are supporting most of the important features, which to start any application development and deployment, we are having that support in our IoT platform. So for the application providers, we have got the industry partner engagement program through COI. There the user role management we do, the service subscription management. Whenever an application comes on board, we create a service subscription, and whatever devices are coming, we open the network to those devices. So those kind of service subscription management we are offering. We've got a resource tree viewer. So whatever data is being created by the applications onto the platform, the resource structure of the data is available through resource tree viewer. Through network management, we do through TR069 and lightweight M2M. In case their devices support the clients of these protocols. And application resource management is also done, where we assist. We have got a utility where we assist the application providers to create their data resources in a very easy way. So that more details, again, once you come on board to COI, you'll come to know how easier it becomes to use an application resource management, because these are the features which are available to parties who are coming on board onto our CCSP platform. So our solution set, it is comprising of basically INCCSP, which is the infrastructure node. MNCCSP, this is a field node, the gateway device which I was talking about, and IoT device organizations who are having IoT gateways, they can use our MNCCSP to port onto their gateway devices. And then for the application devices where only the application is residing, we can offer ASN CCSP. So this is our CCSP portal, where you will find links for how to, team will get back to you on how to onboard onto CCSP. So in a nutshell, the benefits of CCSP is that since it is 1M2M based, you get the benefits of the evolution of features, which are basically collaborative evolution of features from the expert around the world, and the common problems which are being faced in the IoT industry, they are getting addressed in a much faster and structured way. It benefits the procurement agencies by offering the ability to commission multi-stage projects without locking into a single technology or vendor from the very onset. Using CCSP, IoT solutions can interoperate across silo boundaries, and it also enables innovative solutions because data sharing is enabled through this platform. And therefore, it is ideal for distributed and cooperative solutions where data is being generated by two different parties, and those parties can share data to a third party to come out with a more intelligent solution. As far as participation is in various events, we have had 4 number of 1M2M developer events which CDOT organized, and we had workshops also. In the developer events, we invited various organizations to come and see how we taught them how to write 1M2M application, and that was a 2-day event we had been having. We had in Delhi as well as in Bangalore. Then we have attended 6 1M2M interoperability events where we take our CCSP implementations, which are the IN, MN, and ASN implementation, and we tested them with the counter implementations of other organizations which had come to participate. And these events have been held in South Korea, Taiwan, Japan, where the teams have gone. And we have tested with 12 organizations for the interoperability. We have demonstrated CCSP with various applications like smart living, fire safety, traffic control from within CDOT and across basically other private organizations also. And as of now, 35 organizations have already registered on our COI. So these are some applications which have been developed in-house and which are also deployed in our CDOT campus. The smart living, which is involving temperature, humidity, and power monitoring, and also our HVAC control. We have a canteen feedback system installed. Then there is a vehicle management system which is installed when you enter our CDOT premise, CDOT gate. There, basically, the number plate is recognized, and if it is of a visitor, or if it is of a CDOT staff, and accordingly, the boom barriers are open. So this is also 1M2M based, and then the emergency alarm, which is installed in the ITU premise, and there is a patient tracking application also, which is ready. So in-house, we have also had smart street light pilot for LoRa as well as 6 LoPan based solutions. Then we have assisted fire safety and healthiness monitoring application. And then we also did a POC with CDAC for traffic light control and monitoring. So this is the smart vehicle and visitor management, where whenever a car or a vehicle comes, the camera installed there checks the number plate, and it checks with the database of the CDOT staff if it is of a CDOT staff or a visitor. And accordingly, the boom barrier request is sent from the CCSP to open it or close it. Okay, so CDOT also has been a very active contributor in 1M2M with respect to the chair and vice chair roles. We are part of the SDS working group vice chair. Also, we are holding the position of Marcom vice chair. We are a reporter of the field device configuration technical specification. We have been contributing in HC 1M2M task force, where HC takes people from the industry, the technical experts from the industry, and it is writing the test conformance suits for 1M2M. And we participated in 2021, and we are part of the committee in 2022 also. And we are also now the reporter of 1M2M conformance test suit, that is TS18. So these are a few of the technical plenaries we have been attending in France, Bangalore, and Spain, South Korea. And we have around 440 contributions, agreed contributions, which we presented in 1M2M forums, and they were agreed by the various participants. We have done interoperability testing with InterDigital USA, LAS, CRNS France, HP USA, NTT, KT, DECRA, Sejong University, III Korea, Synco Techno, and Acme Germany. So what do we mean by interoperability testing is that we took our CCSP, IN CCSP, and they brought their MN or ASN CCSP, MN or ASN nodes, and they tested with our CCSP. We also tested with, we took our ASN and MN and we tested with their IoT platform implementation, 1M2M based. So that's how we did the interoperability testing. And it is a around 7 days event, which is held, and a very thorough testing is done there. Even conformance testing of CCSP with ETSI, test tool and Spirent was successfully done. So these are a few events which we have hosted and participated. And other contributions which have already been covered by various speakers is that we have been contributing in the BIS LITD 28 specifications, and in the Intelligent Transport Committee also in Niti Aayog we had submitted our recommendations, and we have contributed in the technical reports of TEC comprising of gateway architecture, 13-digit numbering plan, communication technologies, and security by design, and IoT experience center. That's all from my side. And for any technical clarifications, you can contact me. And for any financial clarifications with respect to the usage of CCSP, you can contact our marketing team headed by Mr. Ravindra. And one more thing, that CCSP is there for deployment if any organization is ready to take it for deployment. We are open for discussions on that, and we have got various models for deployment. It is cloud-based also, and Docker-based deployments are also available. Thank you.
Thank you very much, Anupama ji. The floor is now open for question answers. Very briefly, we'll take 1 or 2 questions for 5 minutes. अगर आप किसी भी पैनलिस्ट से कोई सवाल पूछना चाहते हैं तो kindly come forward. माइक किसी के नीचे फ्लोर में माइक किसके पास है? हाँ पैनलिस्ट के लिए यहाँ आगे.
Thank you very much for excellent presentations. I have 2 questions. One is, in release 4, you said that it will be focusing on the time management. So what do we exactly mean by time management? And the other thing which I wanted to know was that on one hand, TDC has made some certification, GIS is also making some certification. So is there a requirement for having 2 bodies getting involved in it? Can't be a text made by one body to make things simple.
Yeah. So coming to the second question first. TEC is making specifications while TEC follows ITU. While TEC follows ITU standards, BIS follows IEC ISO standard as was highlighted. So both the bodies, the ITU focuses, and there was a presentation that ITU collaborates with 1M2M. So TEC with the 1M2M and this, and basically on the equipment technical specifications on the interfaces. While BIS, as I could understand, is basically on the use cases, extensively on the use cases, and we also within TEC and BIS collaborate. One of our team members, he has a talk tomorrow, Mr. Sushil, VDG. He heads the corresponding committee in IoT. So we collaborate and we try to see that there are no.
With us, I will add to that. See, I'll clarify the whole scenario around it. First is TSDSI, being one of the 8 SDUs, owns 1M2M. Right? They are partner type 1. So there are 8 SDUs. Unlike any other standardization bodies, where some organization who develops a solution and puts it across to a SDU for converting that as a standard. Right? Then the lobbyists are actually lobby around them to promote that as a standard. Contrary to that, 1M2M is a partnership program wherein 8 SDOs, they are all partner type 1. TSDSI is one of them. They have their members who join their heads together to create the specification. Now, this one M2M standard, one of the 8 owners is TSDSI. TSDSI transposes this and sends it to DOT for adoption request. TEC then puts up a consultative committee, CC, and a TSAT, Telecom Standards Advisory Committee, which is an apex body, to decide with larger consultation with the industry and the entire user space, whether that can be adopted as a national standard or not. So that deliberation, those discussions about whether that can be adopted as a national standard, that happens in TEC. In BIS, there are different divisional councils, and alongside that, there are different panels. This IoT reference architecture was one of the panels under LITD 28. That LITD 28 was actually discussing and standardizing the ICT, the smart city ICT framework, right? The reference architecture for smart infrastructure. Smart infrastructure would have been incomplete without IoT as part of it. So one panel 9 was formed under LITD 28, which actually was working towards the reference architecture. Because from a national perspective, BIS is the standardizing body. So an overarching. So in BIS, in order to harmonize the efforts between two different standardizing bodies, we partnered and gave reference to the standard already defined as a national standard in TEC as a normative standard. Alongside, we also took cue from the international global standards, as Mr. Sir has just mentioned, IEC, ISO standards regarding the IoT thing. So we had to harmonize the international and national things so that the audience and the readers don't get confused about it. And there is complete harmony towards one common standard. So that happened because of this kind of a effort. Am I able to clarify that? And I'll request Anupam to talk about the time.
Yeah. So with respect to time management, it's a new CSL which is coming up in release 5 of 1M, where the requirements of managing the time synchronization between devices is going to be discussed. Thank you. Other question? I have one question for Mr. Mehrauli. So this is regarding IS 18004 architecture description you showed to us in one of your slides. So I would like to understand the difference between service layer architecture and the functional architecture. So there were two parts of it.
Hello. Yeah. So, see, there are different models. If you had gone through that particular document, so we first took up the concept model, and then there were reference models. So those reference models had components, like we actually broke it down to entities, and what are the different entities in an IoT ecosystem, then what are the different domains and a relationship between them. So when we came down to the reference architecture part of it, the reference architecture was seen as a view from both the sides of it, and we cover the domains as well as the entities. So if you see, the reference architecture has got a diagram wherein we are showing the service layer as one of the part of it, that is the mainstay. So that service layer and its associated components are part of both the models, and the primary objective was to make it open so that only the normative references are referenced in order to get a deep dive into the specifications. It was only a reference architecture. It was not the actual specification document. We didn't want to create a specification document there. We were only working towards giving a way towards a ratified reference architecture, which can be followed by different domains, and in order to give a direction towards the normative standards, which are ultimately the national standard that has been prescribed.
This is your describing service layer architecture. And what is the functional? Functional has the whole description, or is it also some reference?
No, the functional architecture is only, if you see the functional architecture, we have also mentioned certain interfaces. Those interfaces harmonize, given the same names, right? So it was kind of an abstraction of what we have already specified into that. So by specifying this, we were kind of loosely defining that this, when you map with the one M2M specification, will map with the interface which has been very, very articulately defined in one M2M. Understand? So this was just a global view of it.
Just to add, in the development of this IoT systems reference architecture, we followed one international guideline. How to write an architecture. So gives a methodology while writing any systems architecture. You have to identify who are the stakeholders, what are their expectations, and what are the functionalities required to achieve. Then
आप लोग लंच के दौरान बात कर सकते हैं. I don't think
it had seen the common service function. There was a service function dedicated for security. We are not prescribing anything new. We are following the standard cybersecurity mechanism. We can talk about that in greater detail, right? There's a session on security tomorrow as well. Okay. Right? So you can talk about that at greater level.
Before of you, I would like to invite Mr. Shri R. Mittal Sahab. DDG.
Hello.
Sure.
series, which is growth of standard-based IoT M2M ecosystem in India, smart solutions in various domains such as fire safety, ये surveillance, smart metering, transportation and railways. We will end this session with a value-added panel discussion. With that, we would like to invite our first speaker, Mr. K.K. Sirohi, IIT Delhi.
आप एकदम जाके आपको खड़े जाना है ना, आप एकदम खड़े हो आपका स्लाइड्स में रेडी है।
ऑडियंस खींच रहे हैं, ऑडियंस तो बाहर खड़ी
with respect to the collaboration between academia and industry and how we see things changing down the line. And with this background, I would like to, introduce little bit fundamental on the research. This has been a very important theme from ever, that research must be more industry relevant, and we really don't know how research can be more industry relevant, but we actually found one thing, that if the research community has got a suitable experimental setup, then this research can become a experimental research. And to keep a very forward-looking research verifiable on an experimental setup, you need this experimental setup to be upgradable at a very fast pace. Because the research, if you're talking about 5G, 6G as a domain, the 5G is over. 6G is already in and at a pace, right? So if you have a capability to develop an experimental setup on which research can be verified, then possibly we can become more industry relevant. And with this view, this academia industry collaboration, we found that to keep that kind of experimental infrastructure is actually not the task of the researchers, and you need industry experts who can develop those solutions as an experimental test bed. So you need a collaboration of not the industry who take the solutions from institute and make a product and sell it, but rather helps institute to perform its main task of research. So with this, we have created this academia research collaboration. And when we have a mechanism, a model in which the people who are knowledgeable on the product development of this latest techniques, then, and this is usable by our research community, which are anyway known for their research worldwide, then if this combination happens, then we would be in the position to create solutions. And these solutions would be, if our industry team are knowledgeable and experienced, then whatever we are evolving, these would be a deployable POCs. This will be a globally competitive in architecture and various aspects. It must be in a multiple disciplines. And since it is today's research which is being implemented onto these solutions, and if you have a smart mechanism of developing these solutions would be really ahead of a state of art. So this is the theme which we are trying to achieve within our institute. And in this process, when we have a sizable technology building blocks, which can be the base for many innovative solutions, then we feel we are in the position to provide those seed technology to innovators, to startups, so that they can create a more valuable and versatile solutions around that. In our country, we have large number of successful startups, but if you look at the number of deep tech startups, it is very less. And because we don't have any systematic mechanism which helps these deep tech startups to support them by a seed technology, possibly we have mechanism to provide the seed money, but there is no mechanism to provide the seed technology for them. So this is something which we're trying to do in our mission as academia industry collaboration. Your defense tactical solutions, industry 5.0 solutions, and then this will convert it into a deployable POCs, and then we have to have
active pilots, which will give us a confidence that some of them will actually be treated as a nice candidate for the global standardization consideration, and we will have essential patents. Then your academic institutions infrastructure must be that each of our institute must have a private network of showcasing all the new research which is going on. And this is something which we are trying to do, a network level measurements and the performance monitoring of our newer algorithms, and want to build those systems and try out in a campus like IIT Delhi before it actually goes for the proper deployment. Now, as a process of this, we have created a end-to-end 5G network test facilities. So one of them which can be utilized, which is being utilized in many cases, can be expanded many places within this country, where on the desktop you have the entire 5G network capability, and you have a ability to modify any of the functional requirement or functional systems within this 5G network. So if there's a 6G research going on, we can adapt this system's requirement to prove the particular functionality of a new research. So this is one aspect. The second aspect is a very cost-effective network in a box of the 5G and 5G advanced, and which can be utilized for developing the use cases. So if you really want to develop the effective use cases, we cannot develop use cases of the 5G of 2020, because 5G of 2020 is too different than 5G of 2022. So you have to have these networks ever growing at a very fast pace, and we have built a mechanism by which we can meet this requirement. If there is a user who wants to develop use cases based on the release 17 and what is being talked about in release 18, this is a team of academia industry collaboration within IIT Delhi is going to meet that infrastructure connectivity requirement for them. So this is something we have proposed, and we want to expand these activities throughout the country in various organizations. Right. So to take this to a very effective implementation stage, we are planning to create some domain-specific center of excellence. When we say a domain-specific center of excellence, that we know that there are certain knowledge which is there with particular domain. Those domains could be defense, domain could be border surveillance, domain could be industry, domain could be agriculture or healthcare. So these are the different domains. So we want to create a domain-specific center of excellence, and our objective is that how do we create a next generation solutions in this. So I'll take an example of a power grid. So power grid, we from last 10 years we have been planning to do a power grid implementation and deploying some 250 smart meters, right? But the way it has progressed, I think something was lacking in the country. We have not defined very clear way forward for the next generation capabilities, and we are still going to deploy large number of new meters based on the older specifications. So this is something we want to solve this problem through this domain-specific center of excellence, where we have very clearly identified the research fitting into the new solution. We create an innovative product and then go for the trials. And these trials gives us a timely input for the policy and regulation of a new field, for the getting us ready for the mass deployment, and also this becomes the candidate, a strong candidate for pre-standardizations. Now, if we are talking about M2M capabilities, we are talking about the quality of M2M. I'm just taking you a little back. What was the key achievement of the 4G networks? So in the 4G network IoT, of course, the broadband IoT was there in LTE, but what came is a very solution to the battery life, solution to the long distance. You have got some 20 dB advantage in NB IoT, and the addressing a problem of a connection density. So these are the very strong outcome of a 4G network. But going forward, this is not enough. The 5G, the NB IoT, which is a fundamentally a good concept, has got certain limitations attached to it. So if you're looking for a latency tolerant applications, you practically find no application which is latency tolerant, maybe 1% of them. And that is the reason your NB IoT networks are still not deployed. Right. So now these problems are being solved in a new category of a device called reduced cap of 5G NR. Now, if this 5G NR comes in, then you will have advantage of those energy efficiency, you have advantage of a range, and also you remove the limitation of a latency. So you have now multiple type of IoTs. It is not only massive IoT in 5G, you have multiple type IoTs, and one of them critically is a critical IoT. So critical IoT means you have low latency, that the time to respond by the network is the key factor. So the low latency and additional higher reliabilities are the key factor of this. So now, if you really want to take these solutions to Industry 4.0, then Industry 4.0 real control systems can be built only by additional capabilities of URLC. Release 15 has found completely unsuitable to make Industry 4.0 implementation. So it is, you have to bank on release 16, 17 and onwards. So this is the game where we need to focus. Now, if you look at the sustainability aspect of this, now if you are doing a digitization, just conversion of a sensor is giving you digital input and putting up some processing on the controller and sending onto the network, this is not a smart IoT system. Just the connected systems are not smart systems. You have to make sure that this is sustainable. If to make it sustainable, it has to be energy sustainable, it has to be data consumption sustainable, and maybe various aspects with respect to the compactness of this, ability to deploy in a very different conditions. So these are the systems are smart systems. So we have IIT Delhi is some of the research over last a few years now converged into the product. And the kind of the system engineering gains we have realized in this, that we compare the power consumption, we got the 99% power consumption savings. So if some system which is the best of the class is consuming say 20 watt, so our system is 2 watt, our system is consuming something like 20 milliwatt, so something like 1/100. So that is the kind of the research outcome would bring a system advantage into this. Similar advantages are there on the data footprint and the cost and etc. etc. If a system which is normally a 10-liter volume system, by applying these techniques, it becomes a small ones and weight is also less. It is not dependent on the grid power. You can utilize in a different way. You can possibly put that system into a flying drone and can utilize these concepts in a very heterogeneous method. So these are the various things which have been trying out, and we are very hopeful that these solutions would see the light of the day. So these are some of these solutions which lies in the pollution monitoring field, in the case of power generation, electric metering fields, and these are very, very practical solutions. And now, since this aspect of the smart IoT has been verified, now we want these systems to be M2M compliant. And that's where our focus is. So system need to be standardized, but to reach a level of that need for standardization, there has to be some innovations into it. So we have crossed at least one cycle, and this with collaboratively with CDOT, possibly we want to do something significant in this aspect, right? So these are the other use cases of M2M, where we are talking not only from the devices side, but also talking from the connectivity side, right? So these are the combination of device and the 5G and beyond private network box, which we have. And based on this, we are now working on various solutions, whether it requires a predictive maintenance for the Wi-Fi ship, or it is also a strategic fleet management for the army and something of this nature. So why I'm talking this, that for many of them, the business case does not exist. So if you are working on a solution which is research driven, your objective will actually be different than the industry objective. Industry will focus and invest only on those areas where the business case is already established. But we at the academia, which is academia driven industry collaboration, where we can try out new things. We don't mind failing in 50% of these aspects, but these 50%, other 50% which we will be successful, which will give the lead direction for the nation. Now, these are the various aspects of the strategic systems to be converted in an IoT M2M solutions. I will skip on them. So major focus is on the industry and also for the other strategic areas. Other strategic areas basically looking for the capability of a network besides the devices, capability of network which is TSN compliant and URLC compliant. Now, so these are the systems which we need to define ourselves. I don't think we can afford to be dependent on the foreign solutions on these aspects. Now, this is one aspect I just want to take you as a last attention, that this is a chart which shows latency and the reliability. So basically, this is the current state of art solutions. We have some amount of latency is defined and the corresponding the reliability. But the trend is to go from the right top corner to the left bottom corner. And this is where the complexity is increasing. So the space which we are trying to address is this space. This is a space which is now under discussion in 18 and beyond. So if you want to develop these solutions today, right? So these are the solutions would certainly be of interest if we are having a clear goal of self-reliance in this field. And the moment we develop these technologies and solutions and we back onto the standardized framework like 1M2M, then we are actually not dependent on anybody else. So this is the some clear message which I want to give here, that we are not only for the standardized solutions, but look for the opportunity where we have innovations, and that innovation becomes a candidate for the standardization. I have a very serious objection for the TSDSI statement that it is standards driven research. It cannot be a practical game. Standards driven research. It is a research which will drive the standardization. Right. So this is the theme which we want. It is only the conference in India where you can have the standards driven research as a theme. Nobody else in the world. I think we are driven by someone. So we need to take corrections in this. We need to solve our problems ourselves, and this collaboration of industry and the academia is the way. And I have worked in CDOT for long. I have seen industry other than CDOT after that, and academia, what we can do. These kind of solutions are actually not possible in the industry alone. So this is a very right mix of CDOT like organization, IIT Delhi like research community, and then we can look forward, be a leader for the entire industry. CDOT was a leader at one point of time where 20,000 crore rupees of the digital switch was being sold every year. But that model was different. We never gave technology to our manufacturers. We gave only the manufacturing technology. We never gave a design technology, right? So today is the game that we are creating that technology. We are willing to give to CDOT, and we propose that whoever is the new companies coming forward for creating these solutions, let's pass on this technology to them so that they can maintain, enhance, and meet the national needs, because the national need is too big and it cannot be imported. Thank you very much. I expect it.
Thank you, sir, for your valuable insight. I would like to invite Mr. Arindam Bhattacharya, Registrar CDOT, to present a memento as a token of appreciation. We would now request Mr. Mithilesh Kumar, Head of Solution Engineering, L&T Smart World for Smart Cities and Utilities Business, to discuss on smart solutions over Fusion Platform, L&T SWC. Welcome, sir.
Very good afternoon to everyone. And thank you, the entire C.Dot team, for inviting me here. Today, I'm going to talk about, and in fact, wonderful sessions from all the speakers. And today, in fact, I'll be speaking about our experiences, what we had into smart cities, how smart solutions and what kind of smart solutions we have created, and we have actually deployed it into various of our smart cities programs. Yeah. Is that okay now? Thank you. So we have structured the entire presentation into basically 5 different segments. We'll just start with a little bit about LNTSWC, about our organization, what kind of experience we had into smart cities precisely. So we are the one of the most number of smart city deployment company in the country. We are actually running more than 25 plus operation centers across. What the third segment is going to be what kind of smart solutions we have deployed, how standards have actually helped us in deploying all these smart solutions, and what is the role of exactly Fusion platform into that. And the last would be the key differentiators from our side. Yeah. So to speak about our company, so we were established in 2015. We are the market leaders in smart cities, precisely in smart cities and digital connectivity. We are end-to-end solution provider. That means when we start talking about the specific sensor components, the specific connectivity, the application infrastructure, and how the integration of all of them is going to help us, the entire solutioning end-to-end is being deployed by us. We are the largest partnered company. That means we actually have more than 40 plus customers as well. We are having a largest ecosystem partners who continuously work along with us in creating and co-creating the various smart city solutions. Very quickly on the business verticals, we are basically divided into 3 segments: safe and smart cities, communication, and military communication. On safe and smart, we precisely talk about all the smart cities solutions. When we talk about smart cities, the requirement of safety and security, the smart utilities, when we talk about AMI precisely, the metering infrastructure, water infrastructure, the entire solutions is being covered under that. And then smart critical infrastructure, which is nothing but domain specific solutions, which is getting covered into airports, seaports, mines. This is basically how an entire integrated operation center can be created within that. The next segment takes care of the next generation networks, which is the complete network advisory, data center and private cloud, cyber security advisory altogether, and definitely private 5G rollouts. The military communication talks about the specific, some of the specific solutions and the products what we have for the Indian Army and defense. And then within that, we are actually covering satellite communication and radio communication. Within safe and smart cities, we have 4 sections. Within smart cities, we are actually creating integrated command centers, urban services, smart campuses, which is the combination of all kind of IoT solutions. For example, when we talk about IoT M2M, how IoT M2M is going to is going to be leveraged by the platforms, how different kind of solutions like smart lighting, smart parking, or any kind of IoT can be integrated together, and how a single use case can be created. All these solutions have been created by us using smart campuses, within smart campuses. Under public safety, we are talking about the solutions on city surveillance, traffic management, traffic enforcement, which is ATCC, ATCS, any kind of ANPRs and RLBD solutions and all. Smart infrastructure is the domain-specific infrastructure, wherein airports, seaports, oil and gas, and mines to create integrated operations. We are providing solutions. Defense, when we talk about defense specifically, under defense, we have solutions related to drones. We have solutions where we are creating digital twins over there. We have some solutions using metaverse and all. And then the last segment is smart utilities, wherein we are creating the complete end-to-end AMI or advanced metering infrastructure, whether it is a water or it is an energy solutions. The baseline for all these services are IoT, big data, AI and ML, GIS precisely, cloud services, and the 5G solutions. Under communications, we are covering the complete advisory on next generation network, which is network design and engineering for a given city, a given campus, a given townships and all. Within data center, we are actually covering the complete build of a data center, which can be cloud services, which can be on-prem data center provisioning, which can be a transformation and migration services from an on-prem to a cloud service, a cloud platform. Within cybersecurity, we are giving a complete advisory of the cybersecurity components, whether it is going to be industrial OT or IoT security or IT OT integrations and all. Under private 5G, we are, as this has been initially started a few months back, but we have started doing a private 5G rollout for a given requirements. Now I'm going to talk about our experience precisely. What we did in last 10 years. We actually got formed in 2014, and from 2014 onwards, we have been doing lots of smart cities, lots of city service projects. We have done lots of AMI projects and all. So just to name a few of them. So we are currently running 25 plus smart cities operation centers, which is currently into operations on all the police, the entire police department, the municipalities benefiting out of that, while while we have created a complete integrated command and control centers while integrating multiple solutions and services over there. Currently, we have deployed 25 plus cutting edge city operation centers, which is again a part of smart cities. We have deployed 5 million world fastest smart meters, which is the AMI rollout, which we have deployed it in Haryana and Uttar Pradesh. So the entire IT infrastructure, including the integration services, has been deployed by us. From the e-governance perspective and e-Shiksha perspective, we are actually connected with more than 6,300 plus universities and schools while deploying the entire the contents of e-Shiksha over a digital network. This is the L&T-SWC footprints across the country. So if you name a state and we are present over there, we have done either in the form of smart cities or any kind of security solutions and all. So almost in all these smart cities, all the the states, one of the smart cities is being deployed by us. Now I'm going to talk about some of the key projects which we have deployed, starting with Mumbai. So in Mumbai, we have done more than 10,000 cameras. We are actually touching more than 6,000 junction points. Each 6,000 junction points are having a cluster of cameras, which is actually transmitting over a dedicated MPLS network. While we have 2 data centers, which is actually consuming all the feeds from the cameras, and it is transmitting it to the operation center. So we are having 3 integrated command and control centers, which is actually managing the entire city. The police department sits over there and is actually able to see what kind of traffic condition, what kind of events which has been managed, which has been happening over there. And in case if any kind of events are happening, the police there itself is able to manage it while getting the necessary information from the system and able to do a quick turnout to all the incidents happening over there. It has actually improved the situational awareness of the department over there. We have there is a disaster preparedness which has happened. we have a public information dissemination. That means from one single location, we are able to disseminate messages to the entire city, while we are actually touched up with 6,000 junction points across the city. Next is the Hyderabad. It is actually a largest safe and smart city for us. Along with the safety and security, we have actually integrated multiple kind of sensor points there. So when we talk about sensor points, the integration is there with the smart meters. The integration is there with energy meters, water meters. We have smart lighting over there. We have the environmental sensors over there. So that is how I think the standardization is going to play a big role over there, because here we are having multiple data sources, we are having multiple systems, and how all these systems are going to get integrated into a single platform, and how the usage of those individual data has to be taken by the user. This entire integration is being being taken care by the platform and the solutions what we have provided. Just to name them, some of the specific highlights of the project, we had deployed 2 data centers over there, which is working on active mode. We had complete traffic enforcement system, which covers the ANPR and RLBD, which is the automatic number plate detection and red light violation detection at all the junction points of the city. And then we have adaptive signaling, which is based upon the signal conditions, the traffic conditions of the city. The signal automatically turns up, and it actually gives a complete green corridor passage, and it actually manages the entire traffic condition of the city. I'll talk about a little bit about Prayagraj. This is the place where we have actually deployed our smart analytics. In this, basically the crowd management for 250 millions of devotees has been done by our platform. What kind of route the crowd, the devotees should take, which is the area where the number of devotees are less, which is the area where the number of devotees are higher, and what kind of passage they should take. This entire information, while getting the individual data sets from the individual sensor components, has been created by the platform what we had, and we were able to successfully manage the entire Kumbh Mela we had last time in Prayagraj. So, and this has become a study in Guinness Book of World Record as well. That with a specific time, within a specified time, how the entire system and what kind of by using what kind of technology we were able to manage this entire show. The next couple of slides will be more on the solution offerings what we had. So from the smart city perspective, each of the point solutions which we actually deploy, whether it is going to be a part of IoT, it is going to be a part of energy management, or it is going to be a part of the waste and water management. This entire solutions are going to be has got deployed into an integrated operation centers. On the standardization, I would like to talk a little bit very quickly. From the design point of view, we actually follow some standards which is based upon the specific set of protocols. We have some integrated service delivery model which is being utilized by the citizens, by the customers, when we go ahead and design the solutions to them. On the design and approach and consideration side, definitely the key parameters like scalability, modularity, integration, data-driven approach, all this is being taken care when we go ahead and deploy the solutions, design the solutions. Very quickly on the integrated command and control centers. So we have a platform which is being utilized for all kind of structured, semi-structured, or unstructured data, whether it is going to come from a camera or it is going to come from an IoT device, or the structured data coming in from any kind of government databases and all. So all these data is being captured and being collaborated on a single platform. Some of the specifics of the Fusion. So with event-driven service-oriented architecture, we are 5-wire compliant. We have an inbuilt data lake wherein the multiple data, which is coming from any kind of sensor devices in being captured, and it is being processed over there to get some needful informations. From the security point of view, we follow RBAC, which is role-based access control, which is given to the specific users based upon the specific requirement of the customer. Very quickly on the solution architecture, as we discussed a lot in the morning also, that we have lots of types of data. So the platform itself is able to consume data from multiple sources, whether it is real-time streams or it is going to be IoT or the legacy systems, because in smart cities, we normally see that the data is going to come from multiple sources. So there are legacy systems which needs to get integrated. And there are the requirement of the project, for example, camera or any IoT devices, which has to come and get integrated over there. We have a specific integration and automation layer where all kind of protocols, all kind of data acquisition is happening, which actually goes to the core engine where the entire processes, the processes and the rule engines process is happening. We have a specific dedicated data analytics layer, which is actually consuming the raw data from the individual integration points, and it is converting to the necessary information. On the right hand side, we have the specific smart solution domains and services, which is actually creating the domain specific dashboards to the users. That means in any smart cities, we have utility as a customer. We'll have the municipality as a customer. So for all of them, we cannot have a single unified dashboard. So we have actually used on a microservices model. We have created the entire visualization layer in such a way that to the specific customer, specific requirements, we can create the complete KPIs and dashboarding to the specific users and give it to them. So that's how we'll have a specific dashboard for the specific users using this platform. I think I have spoken to this. We have some specific analytics as well, which we have deployed in almost all our smart cities, which starts from fire detection, which starts from no mask detection, video enhancement and summarization, which is getting let's say if we have a 1 hour video, and if we want to take out some specific information from that, let's say for 2 minutes or 3 minutes or 5 minutes video, with using this video summarization tool, we should be able to take it out. And this has become one of the very, very useful tool for all the police department, because they have been using this extensively while any kind of incident has been analyzed and can be taken care within very, very few time. We have pothole detection, wrong way detection. Anyway, I'm going to share this presentation, and you may have a look on the entire set of analytics what we have. Anyway, I have spoken about the ICCC key features what we have, but just to touch a few of them, we have a real-time situational intelligence available on the platform. We have cross-domain synergies. That means data coming in from multiple divisions, multiple departments, multiple systems, how that can be clubbed and how a single unified use case can be created. The entire information can be taken out and can be utilized by the given platform. Effective data-driven decision making. That means any kind of incident, any kind of event happening within the city, that incident can be taken up by the application that converts, process it, and it sends to the visualization data layer using the analytics, so that the entire the KPIs and dashboards can be prepared out of using that. From the implementation differentiators perspective, and this is my last slide. So we bring that capability from the execution point of view, since we have actually deployed more than 25 plus safe and smart cities. We have a thought partnership. That means definitely, managing the such mega large projects, we cannot do it on our own. So we had a partner ecosystem, lots of while customer has also helped us lots of time in developing the use cases, while partners, OEMs, all of them have collaborated and jointly created the entire solution, and that's how we are managing all our smart cities right now. Technology solutions perspective, we have a dedicated COE, Center of Excellence, which is currently in Chennai and Hyderabad, wherein we keep on day-to-day basis, we keep on testing multiple solutions, multiple protocols, multiple systems, and in fact, the integration services and all, which needs to be extended, is also being is being tested over there. We are with our experience, we have that capability of doing a rapid deployment because we understand what kind of situation scenarios are going to be there. We have pre-integrated solutions. That means all the adapters today, which is needed for most of the sensor components, most of the solutions are readily available with us. Using that, our integration timeline and integration services becomes very minimal. Some of the awards and accolades what we had it on our smart city programs. That's it. Thank you so much for hearing me. I hope I am on time.
Thank you, sir, for your talk. I would like to invite Mr. Arindam Bhattacharya, Registrar C. to present a memento as a token of appreciation. Oh, I'm so sorry. I would like to invite Ms. Shikha Srivastav, Director C. to present a memento as a token of appreciation. Now, we would like to invite Ms. Vasudha Prasad, Pyrox ICT Private Limited, to elaborate on the advantage of one M2M for their application, fire detection and prevention. Welcome, ma'am.
Good afternoon to everyone present here offline in the auditorium and also online. I am from Vasudha from Pyrox ICT Private Limited. We have developed fire detection systems, and we have also developed a monitoring system for the entire fire protection and detection systems. And being the lead for the development, I would like to present how one M2M has provided us a good platform for developing these monitoring systems. So first of all, let us understand what is fire protection system. So fire protection system mainly consists of three parts. That is a fire detection system, the fire extinguishers, and hydrant and sprinkler systems. So for convenience and for easy recollection, let us just call them as the fire trinity. That is the fire alarm systems, extinguishers, and the hydrant and sprinkler systems. Now, these are the systems which operate at the background. So you don't see whether they are working on a day-to-day basis. And any breakdown of these systems will not affect the day-to-day working of a building. And hence, many times, these systems are not maintained well, and they are not repaired on time during a malfunction or during a breakdown. So this leads to fire protection system not being useful when there is actually a fire catastrophe. And thus the continuous maintenance of a fire protection system becomes a very important and is of prime concern. Hitherto, the monitoring or maintenance was done in a manual way, that is on a manual basis, where you all would have heard about fire drills, where a person comes, operates the systems, and sees whether it is working and decides on the healthiness of the system. Now, this is all manual, so this is always prone to error, manual errors, omissions, oversightedness, etc. Our company, for the first time, developed an automated fire healthiness testing system for the fire protection system. This, we call it as a FireReady.net. wherein the fire readiness and the fire emergency system is monitored. This fire ready system monitored all the three subsystems, which is the fire detection, extinguishers, and the hydrant and sprinkler system. And this was done by actually operating the system through remote instantiation and ensuring that every component of the system is functional. So, and any failure in the system would be reported automatically to the concerned stakeholders, and there would be repeated reminders sent till the system is brought back to its function or it is rectified. However, very soon, after we deployed the system, we found that we understood that, achieving continuous fire readiness requires contribution from various stakeholders. And it is not just about one particular maintenance agency or owner or anything like that. It is about an entire environment, a society, which has to work in collaboration to ensure continuous safety. Now, for example, the investment, say now a fire protection system is not functional. The investment required to bring it back into a functional position it requires that the Resident Welfare Association pumps in that money, and they will not be ready to do it unless they are continuously they are given repeated notices from enforcement authority to do that. Similarly, a manufacturer would not accept or own up to defects unless they are provided with associated data of malfunction on a timely basis. Similarly, we can also say that the maintenance agencies would try to show the defects under carpet for whatever defects are there, in order to avoid any accountability of maintenance gaps which they have created. So we can see that this is a collective effort of various stakeholders pitching in their bit. So each one have to provide their bit to ensure that the fire protection system is continuously functional and is actually available during a fire emergency. It is at this time that CDOT extended its partnership to us, and this is where the one M2M came in. CCSP provided us with one M2M standardized platform where multiple systems, subsystems, and even system components could upload or access that part of data which is relevant to them. With one M2M, the vision of fire-ready city, fire-ready nation can now be brought to a fruition. One M2M, being a general purpose standard that applies to all industry verticals, provides that appropriate platform for various agencies to collectively work with minimum overlaps and interaction to provide a solution. There are numerous subsystems. If you consider a fire protection system itself, there are numerous subsystems involved, like there are large pumps. There is extinguishers, there are detectors, there are hooters, there's huge large diesel engine systems, pressure transmitters, emergency communication systems, etc. And these are all obviously from a large group of different vendors and from different geographies. The availability of a one M2M platform gives a perspective to these vendors, to these various vendors, also to hook on to the one M2M platform. Like the valve vendor would want to provide an IoT-based enabled valve. And similarly, a pump or a engine manufacturer would want to share or upload their data or parameters into the one M2M platform. As of now, if you see, the pumps and the diesel engine manufacturers have their own proprietary platforms, and the actual performance of data of these engines or pumps are not available to general public. And same is the case with fire alarm systems, which has a very controlled and proprietary environment. One M2M has now actually enabled us to view. It is not incorrect, in fact, to say that one M2M has enabled us to view the fire protection system as a system, as a whole, instead of just the subsystems present in it. the possibility of creating a large number of containers or data holders in the 1M2M CCSP to get the desired data as required by multiple stakeholders makes 1M2M very special and game-changing. Imagine a situation, I just want to give an analogy here. Imagine a situation where there are subject experts like, experts in chemistry, physics, maths, etc. And they want to collaborate, they want to interact with each other, and they also want to teach students who are interested. But consider that there is no place called university where they could interact, where they could come together, interact, set up labs, and perform experiments, etc. Then advancement and proliferations in these subjects would not happen. Similarly, 1M2M provides us just that university where everyone comes together, interact, advances themselves and also the university. In addition to this, the availability of platform like 1M2M provides a whole lot of new options, new opportunities to entrepreneurship. Like we have, there is now development of various cross-system analytical tools, training modules, etc. And the possibilities of these kind of applications being developed becomes endless. For example, if I say, in case of our fire protection system, it is not just sufficient that the systems are in a working condition. It is required that the residents, the staff, maintenance staff are aware of how to operate them. So we can always provide them a training module, which is automatically which is given to them through an automatic video link. Similarly, we can also interface this with the home automation system, wherein temperature sensors are provided in houses. Now, this data from the temperature sensor can be used to cross-verify the severity of the fire which has been detected from the fire alarm. So now everyone gets an opportunity to improve their systems using the data from another, from everyone else's system, if I could say so. Now that we have, till now we have talked about the readiness of the fire protection system. Now let us take up the topic of fire emergency. What happens in case of a fire incident? So now if we consider the fire incident happening, then there are more agencies involved, like fire brigades has to be available, ambulance services needs to be available, hospitals are required, traffic police would be involved. Now, and the data which is required by each of these agencies could be very different. For example, the fire brigade or the ambulance would require the exact location of the fire incident, whereas in hospital management system would just require the approximate broad location so that they can check regarding the vacancies available, and also to they also would need to know the severity to accommodate the people be brought in as per that. And the traffic police would require the route which an ambulance or a fire brigade would take, so that they could decongest that route to ensure smooth movement or quick movement. Now, 1M2M standards which allow for any IoT solution to discover or interact with any other IoT device is ideal, as the solution can now interoperate and provide a cooperative solution. The possibilities and opportunities arising out of such seamless but safe interoperability are infinite once there is a standardized platform. If we consider the fire protection system, for example, we need to inform the staircase pressurization unit to operate when there is a fire incident. Similarly, we can inform the lift control unit to stop the lifts during a fire incident. And also, we all know that the electricity is to be cut off during a fire incident. So not just cut off the fire electricity at the premise, this information could also be given to the nearest substation or the electricity office in case they want to act upon it and take some action to prevent further catastrophe to happen. This way, various solutions which has not been thought about till now or which has not been implemented currently can also be integrated into the one M2M's integrated, because one M2M platform has been conceived for use across various industry verticals. Another example, if I have to give with respect to the fire protection system, is you see that every premise has a CCTV system, but there is no premise where there is no infrastructure where there is an interoperability between CCTV and a fire protection system. So the CCTV camera can focus on the location of fire incident if there is this kind of interoperability available. But with the introduction of one M2M platform, this can be easily achieved. And CCTV application could now take the information from the fire system and focus the camera to the nearest camera to the location of the fire incident. Fire alarm system could also interact with access control systems to ensure, to efficiently stop the spread of fire and also efficiently to have a smooth emergency evacuation. And this way, currently, if you see, there's a lot of duplication happening wherein extra fire doors are provided for these kind of evacuation, which all can be avoided with the introduction of one M2M platform. Now, with one M2M platform, it is not necessary that each agency, each stakeholder can have their own application, and the information sent by the fire protection or the fire detection system could be displayed in a user-friendly manner by each of those applications. For example, the fire office could have their own application wherein they display the fire information or the fire readiness of a infrastructure. And if there is any malfunction, they could give notification to the for taking corrective action to the appropriate fire officer, so that they can ensure that the infrastructure under question is always fire ready. And we also have applications like in public address system, also intercom systems. All these are already available in every premise. So we can use these systems itself instead of recreating and redeveloping these systems. In case of fire emergency also, map can be provided to the by the traffic police to the ambulance and the fire brigade to take a route which they have been able to decongest, etc. And one more thing is, this also ensures that one agency need not develop the entire application. So there is a lot of scope for reusability. For example, if there is already a application used by the hospitals to understand the availability of beds, etc., a fire protection vendor need not redevelop this. Similarly, to manage an ambulance in case of fire emergency, a fire protection vendor need not redevelop these application. They just have to integrate it with the existing application to provide a wholesome solution. The one M2M compatibility also allows for stage-wise implementation where new feedback from any agencies could be integrated into the existing solution. This way, the introduction of one M2M platform and fire protection system has opened up a vast opportunity of interoperability with reusability and reusability of existing application. Further to this, now our company has also developed, are in the verge of developing a low-cost home automation system, where again we find tremendous value addition by the one M2M platform. Due to its utility, we are already in talk with various manufacturers to hook up their system into the one M2M platform. For example, our system provides sensors to understand the luminosity level in a room and to take action whether the light needs to be switched on or not. But if we have a curtain control application which is integrated to our system, instead of switching on the light, we can open the curtain to to let in the sun, to if there is sunlight outside. And similarly, we can also have if there is there are air conditioners already pressed, there is applications are there which controls the air conditioner, so we need not redevelop those controls. So in conclusion, I would like to state that which I'm sure everyone will agree to, is that IoT will only remain, it will be known as only Internet of Things unless one M2M platform steps in. Only in the presence of one M2M platform, it can be called as Internet of Things, where there is interoperability. So with that, I take up. Thank you so much.
Thank you so much, ma'am, for your talk. I would like to invite Ms. Shikha Srivastav, Director CDOT, to present a memento as a token of appreciation. May I now request Ms. Malvika Pathak, VP, Samriddhi Automations Private Limited, to discuss about their product, face recognition at edge for law enforcement using 1M2M.
Good afternoon, everyone, on all the dignitaries present here today. So I'll start my presentation with a brief introduction about Sparsh. Basically, we are a manufacturer of CCTV camera with 20 years of experience. We are the first one to manufacture these cameras in India. So all the cameras, we truly embodies the vision of PM Modi. We truly make all India products here in India. All products are designed and developed in India. Now coming to the topic, face recognition at the edge for law enforcement using 1M2M. Facial recognition is by far the most powerful and relevant AI biometric technology. It has a vast ability and can carry out several tasks beyond face detection and recognition. Performing a face recognition typically involves detecting and logging a face, recognizing a face and matching it with pre-registered faces, searching a face or similar faces among the all cameras, detecting and matching with the face and alert in case of any suspicious person has been identified. Now coming to the need of edge computing. Due to the tremendous growth in the Internet of Things application and mobile computing, billions of IoT and mobile devices are now connected to the internet. This generates a massive amount of the data. Traditionally, this data is transported and processed in the cloud servers and cloud center, thus resulting in high latency and significant network bandwidth usage, privacy issues, and high cost. To address the limitation of this cloud computing, there is a need of more computing workload which has to be moved closer to the device itself. Instead of performing computation on the cloud side, we can do the computing on the edge on the device itself. Thus, this will remove the load on the server side. So coming to the face recognition on the edge, deploying a face recognition at the edge means AI technology has to be built in the device itself. Moving face recognition technology to the edge comes with many benefits. Here are some other costs of ownership. Once we are basically computing, AI computing require a high power processor and servers. If we are moving that workload to the AI or on the edge, so that computation cost is basically reduced. Again, the response time is drastically removed because computation is happening on the edge side. So there is a lag which is due to the bandwidth limitation on the internet that has been reduced. Now coming to service availability, so no service is actually successful until there is a millisecond. It has to perform within a millisecond. If there is a think of a scenario once there is no internet and service is not working. So when we are moving this AI technology to the edge, so these vulnerabilities has been removed. Low data and bandwidth requirements is we are doing all computation on the edge, so these limitations are also removed from here. So AI on the edge means we are using a AI chip for the industrial design, so we can, designer can develop a product which are innovative in nature and can be compact. Top use cases using Edge AI. Face recognition use cases fall under 5 major categories: access controls, basically entrance and exits, medical cameras, smart locks, and your smartphones also. Surveillance security, detecting and unauthorized people in warehouse areas. Authorization for KYC for bank, financial and services. Smart retail, collecting statistics on shopper demographics. Health control using pandemic, where we can, detect whether person is wearing a face mask or a face recognition. So using this on-edge technology and one M2M platform, we have developed a product which is called a torch camera. Torch camera is a fully self-contained device which is actually 4G LTE based camera, where we are doing a face recognition on the edge, and we are computing everything on the edge and then transferring this alerts to the control center using one M2M protocol. So this is a high resolution camera where we can, detect 5% at a time, and all this database is inside the device, where we can have up to 10,000 faces in the device, and this is all done on the edge. We have done this POC for this product. We have done a POC with Delhi government, where we have they have given us a database of 10,000 persons, and we have loaded that in our device. And they ask us to identify 10% out of that database, and we are happy to share that we have conducted this POC very successfully, and 100% we have delivered the result. And these are the few pictures from the same POC, where we have where we can see that this is a picture where we have enrolled, and this is the one which we have found. In this picture, we can see that the child is this picture is very old one, and the new one is the latest picture which we have found. These are again from the same POC. These are the few results where we have successfully delivered the POC. And Delhi police is very happy with this POC, and now they are using the conducting another pilot for detecting these unidentified dead bodies or the missing person. They are utilizing this product for that. Here are another application where this technology can be used for aviation, border security, construction, critical infrastructure, law enforcement, and transports. As can be seen, face recognition at the edge empower and support user in significant way. Edge technology has begun to facilitate the adoption of highly advanced face recognition, which is only going to increase in the future. Sparse face recognition is a part of this future due to its incredible accuracy and efficiency at the edge. And we would like to thank one M2M platform, which add more value as where we can integrate our product with other products which are there available in the platform itself. With this, I would like to thank you.
Thank you so much, ma'am, for your talk. I would like to invite Ms. Shikha Srivastava, Director CDOT, to present a memento as a token of appreciation.
We would now request Mr. Gautam Kumar, CTO, IntelliSmart Infrastructure Private Limited, for his talk on smart energy metering. Welcome, sir.
Very good afternoon to all of you. And I would be discussing something which is a little bit far off from whatever discussions we had till now, and I'm seeing it. It's more on the use of the M2M networks or the IoT devices in the end users basically. And typically one of the largest programs which are happening in the country at this moment, and the rollouts of the smart meters. And when we are looking into these mass rollouts of the smart meters in the country, we are also around 225 crore meters are being planned to be replaced by next 4 to 5 years time. And first 10 crore meters are already under bid and under implementation. And this is going on a very large pace. And when we are talking of smart meters, so let's discuss what actually the smart meters are. So when we are looking into the smart meter, when we call a smart meter is typically a part of the complete AMI ecosystem. When we are talking of AMI, basically it's advanced metering infrastructure, and the smart meter is the end device into that. And it's then when we are talking of the smart meter use cases, there's the integrated end-to-end where the smart meter is at the edge. There is a communication network, the data management systems, and the two-way communication between the back-end applications of utilities and typically to the consumer customers or equipments also. So the smart meter as a simply when we are looking at the smart meter and the conventional meters, what we could see in our houses, the only difference which has come is the two-way communication. That's the communication module fitted into that, and a control element, which is the switch, which is along with the control. And then the further to that, the beyond measurement is the computation of various electrical parameters, events, storing of communication, and control events basically. So these technologies, when I look at, it's basically modernizing basically the distribution systems. Our distribution systems last 70 years have been almost in some shape have been multiple development activities have been taken up to digitalize these networks. And RAPDRP is one of the programs which happened 10, 12 years back. And then the government of India has taken up another program to revamp the power sector and distribution sector in typical, and which is under the revamped distribution reform program, basically the RDSS, and the RDSS, when we look into the RDSS program, and RDSS, the main is the smart metering program, basically the AMI rollouts for the distribution system. And in the end, when we look into, it's going to be a prepayment at all in end-to-end. When we are talking prepayment device meters, is as good as what we are doing now with our mobile. Same way it is going to be prepayment. We have already done around 35 lakh meters till time. ESL, this is when I'm talking of, we are talking of ESL projects, ESL Energy Efficiency Services Limited, and we are part of Energy Efficiency Services Limited. And we are been the largest implementer of the smart meters so far. Almost more than half of the smart meters today deployed are being done and managed by IntelliSmart and ESL basically. So some of the new things which are coming in and will be impacting all of us is the tariffs, the way the tariffs are being done, with the way we were billed, with the way we are consuming. So there's going to be a huge change in coming times for all of us, all the power consumers, and I understand everyone is getting to be impacted and affected by this. In this area, when we look in, a lot of standardization activity in the last 7-8 years has been taking place, and typically all the standardization which has been so far been done on the metering activities. In 2014, the smart grid pilot projects have been started with the formation of NSGM, the National Smart Grid Mission, and then further to that, the functional the specifications have been drafted out. We have selected DLMS COSM as the communication protocols for the smart metering. And beyond that, few of the versions have come on 164.4 is typically one of the standards which has come across. which not only define the meteorological part, but also in defining the control, and in the same time define the communication part also, how the communication, how the security would be managed. Security is one of the primary aspect when we are deploying such a dispersed communication devices which are communicating and are at the edge, basically. So some of the, and it is at every house, and it could disrupt our complete grid if somebody get into this. And if 1 lakh or 2 lakh customers, they are able to disconnect, the whole grid will collapse. So that's where we are looking into that. The security part of is very, very important. And this is a critical piece of IoT, I can say, and has been dealt in the same way. So it's going to be basically a critical infrastructure. And in the critical infrastructure definition, the security standards are very, very different than what normal IoT devices we are used to. So these are some of the things which has happened. But in the same time, when we are looking in the last 1 year time, we have now been in a phase where we are doing the deployments in mass scale. A lot of standardization documents have been published, have been adopted by the industry, and this has led to the mass scale production capacity building. And in the same time, when we are looking into not only the production capacity of the smart meters, and also the backends, basically. The backends, when we talk on the head-end systems, the cloud infrastructure for deploying these AMI systems, the various use cases, and the definition to those use cases, data exchange semantics on that side, how the data could be exchanged between the different devices at different layers. So all those get specified. And this has given, but now it's the time to see the deployments. And I can say this larger scale, when we are deploying, I think today, when I look in at this moment, we would be now deploying on 5,000 to 7,000 meters a day per day, putting up new smart meters. And we are trying to ramp up this deployment to around 30 to 40,000 meters, as we have to do the deployments of a few crore meters in coming times. And there needs a lot of standardization activities, not only in terms of the device, but in terms of the complete back system. When we are talking backend system, basically looking into how the meters get deployed. It's just not a simple piece of device which goes on your walls. It is basically when we put up a meter, a lot of data has to be transferred in real time for provisioning that meter. And then bills, you have already a old bill which is coming to you. And we need to see that immediately those meters get commissioned, provisioned in the system in the real time, and you get the correct bill onwards. Your tariffs get changed if you are opting for a prepayment system. So when we are looking into this aspect altogether, we need to see that the communication part, right, has to be very, very robust. And not only robust, it has to be ubiquitous in a way that it is available everywhere and every time. And that's a very important aspect when we look in. And we have spoken about the narrow bands, we have spoken about the wideband IoT, and typically the smart meters, when we look into the requirement of DLMS, which has been very, very verbose as a communication protocol. And though power is not a issue here, power is always available, it is basically powered device. So that is fine on that side. But when we look into the amount of data and the amount of, and the latency in the network, right? We need low latency. And in the same time, we need to see that the networks are having enough bandwidth to deliver the data requirements, which is almost real-time data delivery is required here. Unlike other IoT devices where you have intermittent connectivity, you will be solving your problem. So coming to, as I was telling about, the DLMS COSIN has become one of the standard protocol for, and that's going to be there. It's not going to be changed. It's worldwide accepted. And this will remain with us. And as we are to live with this, we need to see that our data exchange could happen through these, because it's going to be million, another 20 years it will take to replace these devices. So we have to be very, very careful when we are adopting to other communication part and then the system side. The standards are already there at different layers and as well established. And practically, I think in the field we have been proving it the last 4 to 5 years. And so far, when we get into so now the steps which we need to see what need to be done. Right? when we are rolling out such a mass. So decoupling, we are looking into decoupling at different level. As we are talking of interoperability, right? Interoperability is something which cannot be, it has to be at the interfaces, basically, of system interfaces. So one of the aspects which has been started up is the decoupling of the communication and the meter. Because meter methodology, when we look into the meter part, it is already established, I think, a device, and everything has been almost standardized. What has been as a very different pace of evolution is basically the communication. And we have our own experience putting the meter from 2G to 3G, 2G, 3G, 4G, and now on 5G, and the obsolescence of the communication channels, and at the same time narrowbands also, and IoT. We have tried every bit PLC, and then we have been in the countrywide rollouts are happening on the NB-IoT, where basically two communication are being selected, is the RF and basically the cellular. And wideband, narrowband is still been a challenge to us. But narrowband RFs are basically well proven, MES RF, and most of the things are happening so. So one of the aspects which we are looking, and I think the UK has adopted this, is on the decoupling of the communication and the meter. So the meter has a life of around 10 to 15 years. We need to see that the communication get decoupled from the meter. So we could keep on upgrading the comms part, change the comms part, and keep the services live. So this is something which is happening through. In this aspect, a standard model document has already been adopted released by the REC, basically. And for in a standard bidding document has been there, where we are talking of a pluggable module, which can take up. Today, we are mostly on the cellular RF. Tomorrow, something else, 5G could come. And these devices, these pluggable devices could be changed. Overall, when we look into the system is getting complex and complex. When we started up initially, it was a few blocks, right, when we talk of the AMI. But when in the real deployment, today when we look in, the system is getting very complex. System is getting complex because the customers, the end customers, millions of customers are now connected, and every time they are looking into the system, their meters. If you see today in Bihar sort of state, where almost 12 lakh customers are with the smart meters on prepayment, they are in a position to see their consumption in real time. Each one and every one of them. Assam, it is the same way. So, and this is going to be for 10 crore meters, and then for the 25. And the payment, you can pay on the real times. You can see your consumption. You can control your consumption to a level. We cannot say you can control your consumption in terms of switching off, but certainly discoms can switch you off if you have not paid up. And you can control your own devices depending upon your consumption pattern. So some of the work which need to be done, I think, is where the interfaces are basically. At the interface level, we are already been looking in and when we look into communication. So another decoupling exercise is happening, and this decoupling exercise is happening from the communication meters and beyond that, on the enterprise application side, and say head-end systems for the meters, which are very, very technology specific, are now getting into more use case specific, defined, and data semantics, how the data exchange, the APIs. Everything could not be in real time, and the volume of data which get exchanged is sometimes overwhelming. If you see how much data every 15 minutes you are generating a good amount of information from every smart meter, and you need to see them back on your system. So overall, when we look in how the APIs, web services, or the way the data is being dumped into is a very, very typical task as we are sizing up. The scalability, there are huge scalability projects are already on. And when we look into the deployment, so these are some of the things which we have started up defining and making them standards. And that's where we make this National Smart Metering Program a success, is that policy and the guidelines engagement and with the experience system and the processes which we need to define, and at the same time SOPs and the cultural shift in the users' patterns, basically. So this is end of my session. Thanks. Thank you.
Thank you, sir, for your talk. I would now request Ms. Shikha Srivastava, Director CDOT, to present a memento as a token of appreciation. Can we have a huge round of applause? I now request Mr. Anshuman Roy, Director Rosemata, to elaborate on 1M2M based ITS implementation using AIS 140. Welcome, sir.
Good afternoon. Thank you, everybody, for having patience and waiting for listening to the 1M2M different sectors perspective and the plan, what they are planning to do. I'm sure after the nice launch of CDOT, we all are a bit drowsy. But because we are excited about 1M2M, so I would expect that your attention would continue. Thanks a lot to Dr. Rajkumarji, Arindam, one of my close associates, Shikha ma'am, Anupama ma'am, for driving this beautiful initiative. And not only that, driving the industry to participate and contribute. And I know about my team. They feel very excited when they are here. Once they go back to their desk, they all are busy with their day-to-day work. But relentlessly, the CDOT's encouragement and support has really helped us to contribute positively. And we strongly believe that the domain primarily where in our company, the business group I handle, we had a big challenge in adopting 1M2M in India, because it's not a greenfield industry. It's not just now evolving or going to be implemented. Mr. Gautam mentioned the smart meter is probably deployed in huge quantity, that if we want to redo everything, it will take another 20 years. So the intelligent transport systems and telematics in India is, if not that 20 years requirement, but surely undoing everything and getting something new is not going to be easy. So as a part of industry, we looked into it. And before I get into that, we have a habit of being a part of commercial organization to talk about ourselves. We feel very excited about it, but I am sure, the audience would be happy to get just a quick brief. So coming to that, I'll quickly touch base about us, and then what we do in telematics in India, and then the existing standards, what is there in telematics field. And not only standard exists, this has been mandated by MORTH to deploy and implement with a dedicated timeline. So deployment has happened pretty fast and happening pretty fast. Then we have new standards coming up in which would encourage interoperability. And believe me or not, for telematics industry, interoperability is the key. We'll touch the different use cases, because it's not one use case, it can cater to multiple use cases, as Vasudha was talking about fire extinguishers a few minutes back. So the way forward, where CCSP's platform to leverage multi-stakeholders, increasing the data availability and data utilization by various stakeholders can be enabled through existing standard framework, as well as working on convergence of standards going forward, because that's the way to go for any legacy or not so nascent industry. We primarily operate Rosemata Technologies. We have subsidiary companies, group companies, but we primarily operate in transport domain. And we operate with 8 business verticals, have our own R&D, hardware R&D unit. We have a 120-member CMMI development 5 level software development team. But mostly what we do on ground in the industry is in and around transportation. That's an industry we understand fairly well. We work with the automobile manufacturers, we work with the end users, we work with state transport organizations, we work with public distribution organizations, but in and around they are related to their transportation and problems. We touch almost 3 million new customers in a month in different form of our product and services. These are different business verticals. We are the first company to introduce the driving license and vehicle registration card, which I'm sure all of you are carrying in your pocket. If you recall early days, it used to come like a book. And these standardization, technology standardization, doing a lot of activity with the authorities and getting something as simple as smart card implementation way back in early 2000. We are the first initiator of this. The kind of speed governing devices to ensure the road safety, intelligent transport system, which we are going to talk about a lot, automatic inspection and certification centers, and automatic driving tracks. You know how you all get a driving license and get your vehicle passed through a commercial vehicle gets passed into inspections, which they are supposed to do every year or 2 yearly. So there are some automation concepts which are based on video analytics and sensors, which you detect how you drive through a lane, and then you come out, your result is printed. I mean, no manual intervention, no manual marking and giving him a license and all kind of manipulations in that. Same is with inspection centers. We have now taken an initiative of various digital services for B2C, which I guess I would love to talk, because as a part of industry, we hear a lot from customers. Get highly rare chance to talk. So when we get a chance to talk about ourselves, we normally tend to speak. I refrain myself in doing that because time is too short. This is a bit of all the devices what we do, all kind of AIS 140 standard, IAS 16833, AIS 018, so on and so forth, which are regulated and mandated. On the solution side, I take a minute over here just to emphasize on one point. We have been doing it for last 10-12 years, and every time we do a project, it's a use case based project. So when I go to a state transport organization, let's take example of MSRTC, Maharashtra State Road Transport. They need a kind of fleet utilization tool and a tool for passenger information system. This bus is going to come in 5 minutes. This bus is going to, dynamic based on the current location. That's a use case based project. So you have a device, you have a platform. Platform is designed in a way to deliver something specific related to that use case. When I go to petroleum industry, their concerns are theft and pilferages. So they have a different use case. The same kind of device, same kind of platform, but a different use case. So historically, we have done really large projects. MSRTC is the largest STU in India. So it has all your buses have a device. The bus stops are having passenger information boards. There are mobile apps where I can see that if I want to go from Pune to Nasik, what are the buses available? When are they coming? Whether they are AC buses, so on and so forth. Similarly, when we did a very large platform project for Odisha mining. Around 85,000 trucks are connected to that. Their requirement is again pilferage and mining theft and even truck hijacks. So when we do all of this, we realize that all this is happening in silos. One specific use cases, these are oil and gas. I talked about mining, autos, taxis. So what is happening is, okay, I have to say this. We are part of BIS and AIS committee as well. So what is happening is from early 20s, telematics initiative started. Industry started approaching all the customer segments. They came up with their user-specific requirements. So solutions kept on building in silos. Okay, again a device, a platform, and then a completely different UI and algorithms to deliver the business-specific values. So this continued. Then came an incident, unfortunate incident like Nirvaya, and then government started feeling that we need kind of framework for a telematics so that every passenger vehicle can have a traceability and an emergency alert system. That's how AIS 140 standard got evolved. And along with that, obviously, for considering it is a taxi or a truck, etc., BIS adopted it with multiple annexures for multiple user segments. So this is already in place, and as North has mandated, as I mentioned, huge amount of deployment has happened. Now, how do we go from here? Okay, so one side, we need a convergence of all these standards coming up, and another side, we need a bridge, okay, to manage the existing deployment and take the advantage of CCSP for our stakeholders who can still use the data. So this is where the current scenario in telematics industry is. Just for AIS 140 devices, there are 1.5 million devices fitted in vehicle already. There are about 12 states who are in the process of implementation, and about 1 to 1.5 lakh million devices inventory are in pipeline to get fitted starting from tomorrow to next probably 6-8 months. So this is the premises we started working with CDOT and started working on our interworking proxy entity, okay, as a bridge. We named it as CDOT Rosemata 1 M2M AIS 140 clubbed up together cross 140. Okay, so which will give a bridge to cross and would bridge the existing standards and 1 M2M utility together. Now, if you look at it, 1 M2M adoptions, theoretically, you have greenfield sectors, which I just mentioned, where you can straight away get into IS 18004 framework and get 1 M2M, the standards, protocols, and communication implemented. Then you have sectors where you have existing deployment, and in that you have two. One is governed by proprietary standards, but deployment happened, and another is already governed by some Indian standard of BIS or AIS or TEC or other committees. So in that, where existing deployment has already happened, you have two approaches. For a proprietary sector, you need to get into 1 M2M framework, the second line, which is one part going to the 1 M2M framework, and second part is need to be driven by a kind of sector-specific middleware requirement, which manages this existing one. Same for existing IS standards. Here, you don't need to get into IS 18004. There are standards already existing. So there has to be a convergence of those standards. And in parallel, there is a need of a middleware like Cross 140 we are talking. So we took a three-phase approach. First of all, if I just go to what AIS current existing architecture is, the device sends data to state government servers. Device sends data to an emergency response server in case panic button is placed. So both communication can happen parallelly. And there is a third IP to communicate to other, maybe the device manufacturer or the vehicle manufacturer to use it and offer various value-added services to their end customers. What we did is, as phase one approach, we picked up the current server we are using for our own AIS 140 deployment, which is already huge in number. We jointly with CDOT started working on this bridge from our server with a RESTful API connection to this cross platform, from there to CCSP. Okay, and the second model, what we propose to do here is the line 2 is instead of our server, because there only our device data resides, the state government server, which is there in the current architecture of data communication, we can use this bridge to pick up the data from state government servers and give it to CCSP. The same middleware, instead of connecting into only my device servers, we will connect to the state government server to pick up all data. Third phase is obviously what I said is ideally the device should come to CCSP, state government, be it state government, central government, emergency, they should take data from CCSP. But in a current scenario, that doesn't seem to be a feasibility in next 6 months, 1 year, 2 years probably, because it involves a lot of standardization body to work together. So this middleware would remain very relevant as per our understanding for at least next two years we can foresee, and still manage the existing deployment which is ongoing and take the advantage of CCSP for other stakeholders. So this is the plan which I already talked about. Quickly, I'll jump into this. This is the current AIS infrastructure, which I already said. There are government servers, emergency servers, and private servers. We are doing the pilot on our private server. Eventually, phase 2, we move to government server. This is cross one, what I just said. We plan to do. Finally, the CCSP platform takes the data from the device and concludes it. Thank you. Thank you, everybody.
Thank you so much, sir, for your talk. I would request Ms. Shikha Srivastava, Director CDOT, to present a memento as a token of appreciation. May I now request Mr. Akshay Mishra, founder and CTO, DSP Works Automation and Wireless Network Solution, to shed some light on 1M2M based use cases for railways.
Just a small change in schedule because we have an international speaker lined up. After Mr. Akshay Mishra speaks about his offerings from DSP Works, we are deferring the panel discussion for half an hour. In between, there are two speakers, one from Brazil, and we are basically shifting the agriculture session in between, and we'll try to wrap it up as early. Sorry for the inconvenience. This to all people who are online and also the audience present over here. So the panel discussion will be held after this. I think we can have a tea break also in between because that is also pending. So we'll have the agriculture session immediately after Akshay Mishra finishes this talk. Thank you very much and thanks for cooperating.
Good afternoon all. And I'll try to not hold you long for your tea and share some details in terms of our experiences and our expectations from 1M2M. So we are a devices company. We are based in Bombay. We do solutions on IoT, which encompasses LoRa, BLE, Wi-Fi, as well as 802.15.4. And this has been our journey. We started with 802.15.4. We have deployments in the field of few tens of thousands of devices, 802.15.4. Then we move to LoRaWAN. We have some BLE devices, and we also have demands for Wi-Fi. And these are spread over predominantly smart homes. We are ODM for some leading OEMs in the country, as well as solutions in LoRaWAN for smart city or smart infrastructure for railways and some other PSUs. And the requirement is that we need to commit all of this for home automation. We need to provide a 5-year, many a times 5 years continuity. We don't know whether technology will continue, prevail, whether the chipsets will be available. So how to maintain that continuity is something which is a big requirement when we are designing a solution, when we are providing a solution. So a standards-based approach, how to ensure that the device, if replaced, my app continues working, my cloud continues working, is something which is a big challenge. As well as ensure homogeneous deployment. So we are talking to some PSU or some railways, irrespective of the protocol, the range, the data rate, the battery life, they say they will give us a requirement. Some requirement may take a LoRaWAN kind of a requirement device, which is far off, maybe 2 kilometers, 1500 meters. Some are short span, some are within a coach, but there is a lot of interference. So how to talk to the customer so that there is a homogeneous solution as far as the customer is concerned, but the technology is ubiquitous and available to the end customer or the user without any hindrance and for a long term. So these are some of the challenges which we see day in, day out. There were some of the things which were pointed out earlier by IntelliSmart and Rosmata in terms of their experiences, in terms of how they're handling it. And we are doing it diversely over home, over industries, and we are facing this thing. So whenever there is a new requirement which comes in, it is something which brings sweat in terms of how to handle this, how to take it up. Home automation, these are some switches over multiple protocols. These are in the field, and we are worried and concerned about the continuity. I'll not spend time on this. This is our railways device. Again, I'm not spending time on the device or the features. We can discuss offline if you're interested. These are 4G and Wi-Fi as well as LoRa-based solutions. This is a gas meter. Again, in a gas meter, the end customer, this is a smart AMR which is deployed in the city of Mumbai. The one with our logo on top. This one. Now, here also, the end customer is not always sure that they will continue with the same technology. It is LoRaWAN once. Now, with the new requirement, they change to NB-IoT, but the head-end system should remain the same. And for a backward compatibility, should we go visit the house, change the meters? All of these are questions which need to be answered not by the customer, but by us when we are accepting the requirement to offer a solution. Because there are 10 years of operating assurance we need to provide, 10 years of battery life, as well as product and spare availability. So how to adhere to this is something which is a constant challenge, for which we seek the 1M2M kind of a framework. For the upper end as well as for lower end, we require some other devices that which I'll put some thought and maybe leave it open. So Indian Railways also has many other operating challenges in terms of the time availability of a coach for installation, testing, deployment is very short, maybe half a day, maybe 18 hours, where we have to install, test, and get the coach out. Because this is a turnaround time they expect, where they clean the coach and the coach is sent again for the next trip. So this is something which the technology cannot take longer in the operating, in the installation, as well as during the trial phase. And the multitude of technologies which come together opens up a requirement of a fabric which makes sure that all of these protocols talk consistently to a common media framework, a common technology framework. And while that takes care of only the upper layer, I'm still repeating the same thing, that the upper layer is taken care of in terms of my interface, the business intelligence, the head-end system. But there are other lower end systems which also needs to be handled, which is not currently handled even in 1M2M or our TSDSI framework. But a standard implementation is something which is very important even there. I have skipped the earlier part. We can take in detail one-to-one or in questions, but I wanted to come to this particular slide, which was a little, I think, a little more interesting from our point of view in terms of questions and how do we proceed further. Is as a small design house who has acquired a customer, it is in my best interest to keep the implementation proprietary, not keep it standards-based, so that I can keep the customer with me perpetually. This is in my myopic interest, and we have fallen to this particular trap. And we have seen many people falling into this trap. Let's give them something which is proprietary, and it does not sustain. We fall face forwards. Customer will not talk to you. Customer will be so. It is best to make sure, trust and treat everything and share everything with the customer in terms of the longevity solution, the requirement, and the technology longevity. And that is something where a standard implementation is something which is very important. However, both our private customers and the government customers, they are least bothered about looking at TSDSI or a standard. Their only thing is cheapest cost, fastest turnaround time, give it to me. They will not listen. They will not attend to any of the standards document or their whatever you speak in their own interest. How to solve this? I believe TSDSI has a role here in how we are. I would say that TSDSI is a startup. So the way we treat a customer and go and sit with them, maybe TSDSI has to go and sit with the customer and maybe solve their problems or tell them that this is what a standard will help you and this is how you should write a tender. Unless a tender is written, a developer like me or many other like me will not adhere to the complete standard. We will cut corners. we will make sure that the customer is happy. We will not make sure TSDSI is happy or the standard is implemented or not. To bring this, I think TSDSI will have to put in some effort. What I am too insignificant to answer that, but I think there is a big gap there. The other thing is CCSP addresses the upper end, the business logic, the interface to the customer. But now as our devices are increasing and now there are CAGR number 35%, 40%, I think they're all nonsense. The IoT requirements are going by 1000% or 2000% in terms of the requirement that we are seeing. Almost everybody wants an IoT device. Almost everybody wants a sensing device. You pick up a problem. I'm sure there is an IoT solution which can be catered, but you may not get some profit in the next 1 year, 2 years, but there definitely will be a good opportunity to grow it. However, the problem lies in once the devices are deployed. If you want to maintain continuity, it is only a single protocol, a single RF channel. Today, after 5 years of working in this particular domain, I cannot guarantee you that this particular thing will continue for the next 5 more years. Whether the 865 to 868 megahertz is sufficient for this, whether the 2.4 gigahertz Wi-Fi is sufficient without interference for the next 5 years, 8 years. So there has to be some smartness in the devices, some smart sensing in the devices in terms of an SGR-based implementation, where the protocol, the RF frequency can dynamically change. These things will be required if we get looking at standards in the country when we reach out to the end customer. Otherwise, we'll be again repeating what happened, what we have seen in the smart metering in the last 15, 18 years. I was very happy to see that there is a deployment of about 5,000-7,000 pieces, units per day. Otherwise, what we have seen is we have seen many states, they did a smart meter, they put BLE. There is no mention of the deployment. There was 1 million meters, no mention whatsoever what happened to them, what happened to the technology. They were again looking for a tender in the next 5 years or the next 3 years. So these kind of failures, it's public money after all. So how to solve this is something which I feel pained. And I think that this is something which should be addressed collectively and not in our, what I mentioned in the first line, myopically, that let's take it up, let's do it. How to do it is what I seek input from CDOT and from all the members here, attendees here. And I think also from TSDSI that the standards should have some, what I mentioned in the last line, a commercial success story, short-term, long-term. Somebody will have to be given advantage in terms of, yes, these people have benefited from a successful standards with implementation. Unless that comes, many others will not be motivated. The customers are least bothered. So how to go about it is something which I think we need to address, we need to solve. Otherwise, I think smart devices we have done. I don't think making a smart device is such a big challenge. Technology, we are all very, I think, tools are available, technologies are available to design, develop, manufacture. Also now India is opening up. We can manufacture large quantities, but unless we get our approach right to have a sustained long-term design-based standard-based implementation, I think in the next 5 years, we'll again be regretting that we missed the opportunity again when we could have done it. So this is all that I would like to end with. And that's it. Thank you.
Thank you, sir. I would like to invite Ms. Shikha Srivastav, Director CDOT, to present a memento to the speaker. We'll be starting with the third technical session in this series, which is IoT applications for agriculture. In this session, we'll learn about the use of IoT in the agriculture field, along with standard-based deployments in agriculture. We'd like to invite our first speaker, Dr. Rabi N. Sahu, Principal Scientist and Program Leader, ICAR, Indian Agriculture Research Institute, for his talk on agriculture sector. He'll be joining us online.
So you have been given the rights. So you can access the screen share option at the top, bottom middle of your screen. Bottom middle. Which one? Sir, am I audible to you?
Yes, very much.
So you're not audible to us.
Okay, just a minute.
So you please press Control R and try to rejoin using the microphone option.
I have done it.
Yeah. Yes, audible now, sir. Audible now.
Let me put my video on also.
All right, sir.
You able to see me?
Not yet, sir. Are you? Yeah.
Yeah. Now I'll go for sharing.
Yes, sir. Visible now.
Can you unshare this? Somebody's side is there. Unshare the screen.
Yes, sir. You can use the screen share option in the bottom middle.
I have done that, but somebody.
You select the entire screen option, sir. You'll be getting 3 options. Yes, it started.
Is it visible now?
Sir, yes, your screen is visible, but it is forming a loop because you are sharing the same window. Kindly share your presentation window.
Yeah.
Yes, sir. It's all right. Fine, sir. The floor is yours.
Again. Yeah. So good evening, and thank you very much giving this opportunity to talk something about IoTs in agriculture. So my title I've given over here is Disruptive Innovations for Smart Farming. So I think IoT is one of the innovations, rather disruptive innovations, which is going to be used for. And when you talk about smart farming, it's nothing but the smart way of farming, and what are those tools and techniques is all those are listed over here. And one of those is listed, which is in the font, is the IoT. That's what I'm writing over here. So I'm not, because of the time paucity, I have only a few minutes to stand and share whatever my experience on the IoT. So that's why my challenge is making it possible in real time is the challenge, and how best whatever the tools and techniques we develop.
Sorry to interrupt you in the middle. So voice is not clearly audible to us. Do you have some internet problem at here?
No, I don't have, I think. Is it okay? Are you able to hear me?
So yes, we can hear you, but the voice is actually breaking in the middle. So can we try by switching off your video? You can try once.
I think I should do that. Let me switch off my video. Yeah. Is it okay?
So your screen share has also stopped.
Is it visible now? And I'm audible?
So the voice is breaking. You are audible, but it's not that clear. And the screen share is also not visible to us, sir. Do we have an option to connect with some microphone? Because you might be connected by a laptop and you are using that internal microphone. We suspect that.
Mac only.
Yes, sir. Mac will use over Safari. So I hope you are accessing this using Safari browser.
I'm using Chrome only.
Sir, you please try with Safari once.
I close everything then now.
So you may leave. You may leave this meeting and you connect using Safari browser, please. Will it be possible?
Now, I have joined now. Can you check it? It's not clear? Okay. I think we should go ahead with this because of the time constraint at your end. I should not. As you like, you tell me. Okay, no issue.
Hello, Mr. Gustavo. Hello.
Yes.
So, Mr. Sahu, we will be taking you after one presenter.
That's
Please.
Why?
Okay.
No issue.
Mr. Gustavo, am I audible to you?
Yes, you are audible. Yeah.
Sir, am I audible to you?
Yes, yes, you are audible.
No, no. Mr. Gustavo, am I audible?
Yes, yes,
Yes,
you are audible.
I can hear you guys.
So you can,
hear me?
yes, you can speak now. They have given you the rights, presenter rights.
Okay.
Below
Let's go
by
ahead.
the using the arrows, you can change your slides.
Okay.
Okay,
Thank
sir.
you very much. May I start?
Yes, sir, please.
Okay. Good afternoon, everyone. My name is Gustavo. I am a connectivity solutions manager at CPQD research center here in Brazil. Are you seeing my slides? I'm controlling here, right? Well, CPQD is the largest R&D center in Latin America. We have more than 1,000 employees. Our site here is more than 306,000 square meters, and we act in markets like telecom industry, financial, defense, energy and utilities, and agribusiness, the theme of our presentation today. What is the Brazilian agribusiness context? More than 23% of the Brazilian's GDP comes from the agribusiness sector. $122 billion on exports. This is a number that is up to October this year. We'll have more than that. It's a record on the exports of agribusiness products. And we have more than 90 million hectares of unexplored areas for farming yet here in Brazil. According to UNO, one of the challenges that the global agribusiness will have in the future is to feed up to 9.7 billion people by 2050. The global food production has to raise 70% under a climate changing scenario. So it will be a challenge for us to expand this productivity, and Brazilian production should account for 40% of this global production growth. But here in Brazil, we have different realities and different challenges when we talk about the digital agriculture. We have here some areas and some production that have the top of the technology, like precision agriculture, spraying with drones, but we also have regions that doesn't have even connectivity. There's a case here, the guy under here on the left is a student that during the COVID pandemic, he had to climb a tree using his family cell phone to watch classes online. So it was a case that is very known here in Brazil, and he appeared in a program show, and got a satellite link to study, but it's a reality of one people that is shared by many. And when we talk about digital agriculture, the same is real. We have here a lot of production that has a lot of money, but the smaller producers, they don't have money to support such kind of technology in many times. So one of the challenges is not just the technology. We have to present a solution that is inclusive, sustainable, to bring the digital transformation to agriculture as a whole, not just for those who have the money to invest in expensive infrastructure, expensive solutions. So here at CPQD, we work in the innovation side, bringing solutions for connectivity, for applications, but as well trying to bring some processes that get the adoption of this technology by many people that sometimes are illiterate on digital technologies, with training and diffusion. This brings to the agriculture predictability, quality, and productivity. The challenge here, when we talk about bringing digital solutions to the agribusiness, there was a research here in Brazil, and they asked, what are the bottlenecks for access and use of these digital technologies? We are seeing a lot of innovative startups and companies bringing new solutions, but sometimes it doesn't reach the people that are the demand for these solutions. And this research brought us some insights, like only 23% of the farming area in Brazil has some kind of connectivity. We're talking about 4G, 3G, Wi-Fi, LoRaWAN, whatever, but only 23% has some kind of connectivity. And if we increase the connectivity to 48%, this would increase our gross production value by 4.5%. We're talking about a $10 billion increase in this production. If the connectivity was of 90%, we would have almost the double of what is presented before. And there are some research here that present that with 5G, we have a potential to increase by $77 billion the Brazilian agribusiness sector. We have some international cooperation trying to bring solutions that are viable, economic viable, because today, as it is, the big carriers don't have interest to bring connectivity as they bring to the cities, to the areas that have population density that brings them the ARPU that they are willing for. So one of these international cooperation on technology that we did, CPQD, with different universities here in Brazil, as well as European universities and companies, is the 5G range. It was a project that we did 6 years ago. And one of the gains with this technology is that it was using cognitive radio for spectrum sharing with TV broadcasting services, because the UHF band is a spectrum that has a good performance for coverage, and you have to invest less in infrastructure, and this gets the solution feasible to use in areas that wouldn't be with traditional technology. There is also an action here in Brazil of the big carriers with some manufacturers of machinery for rural areas. That is called the Conectar Agro initiative. They are promoting the LTE in the 700 megahertz band, but the model is a little different. They share the cost of infrastructure with the producers that want to install this infrastructure in their farming areas. So it's a different model from the public telephony that we have here in Brazil. CPQD has a history in research and development of technologies for rural connectivity. We started working with LTE for the 450 megahertz band in 2009. It was standardized by 3GPP on 2013. This band is really nice as a coverage solution. It's standardized. It has an ecosystem of IoT devices. So it's a technology that we bet a lot. But the big carriers that had the spectrum here in Brazil, they didn't use it. And today it's getting back for private use. We also had some initiatives in the 700 megahertz band. And there was a development here in Brazil that today it's not only CPQD and the industry that we transfer the technology that has the solution, but we also have other industries here in Brazil that are competing with a non-standardized LTE solution on 250 megahertz band that provides a solid coverage in underserved areas. John Deere signed a partnership with the industry that is commercializing this in Brazil. And even a mining company that has a large project for railway coverage here in Brazil. And today, CPQD has a project that is funded by the Brazilian government, 2 projects, in fact, that is working with Open RAN solution technologies that are feasible for rural areas. This LTE solution, we developed the eNode B, but also the terminals, because they are not standardized. You cannot use the mass market solutions. So we have to develop the proprietary solutions for different applications. This is employed on the largest sugarcane producer in the world. It's called São Martinho. And they are using this for 5 years now, 6 years. And you can see here that this technology has a large coverage area for areas that go more than 70 kilometers with just 6 towers in the production area. We also have a project here in Brazil to foster the development of technologies and ecosystem for IoT applications to reach to smaller producers. It's called the SEMIAR project, and it has a reference architecture that comprises not only the infrastructure, the connectivity infrastructure, but the applications as well. And we try to bring the ecosystem to be sustainable by itself. We map what are the demands for the producer area, for these smaller producers to share a common infrastructure and applications that will attend their demands. And we try to bring an operator for this area that might be someone that is not a carrier, a traditional carrier, but someone that is a smaller wireless ISP provider, or even a cooperative that we have here between different producers. And we provide to them an IoT platform that CPQD has developed here in Brazil. It's open source. It's available for anyone to try. An AI platform that is designed to attend agribusiness use cases, and a decision support platform for them as well. And we are using a platform, a blockchain platform, as a providers of trust between the producer and the consumer. Here are some digital agriculture projects that we have here, like livestock traceability, smart rural credit platform. One of the use cases that we see a lot here is that the intermediation between the producer and the consumer leaves the small producer with less than 30% of the value of what he produces. So we try to bring them together with this platform. We have projects with bovine facial biometrics, IoT and AI for integrated crop, livestock, and forest integration, and intelligent pollination for with using AI and IoT. Thank you, guys. That's what I had for present to you here. The audio is closing.
Mr. Sahu, am I audible?
Yes. Yes.
Mr. Sahu, we have given you the rights. You can check.
Yeah,
You can share it.
I'm doing that. Just a minute. Give me a minute. So, are you able to see my slides? Hello?
Sir, you can speak, please. Hello?
Is it audible?
But some disturbance is there, actually.
I don't know why that disturbance is there. Just a minute. Hold on a minute. I don't know why.
Sir, audio is not better, sir.
Now it is.
Hello?
Is it? I'm audible now?
Sir, audio is, sir, there is quite a disturbance there.
But I'm from the desktop only I'm doing. And I'm using a landline connectivity and all those things, 100 Mbps, more than that.
Sir, can you share your screen?
Yeah, I'm doing that now. Are you able to see my screen now? Are you able to see my screen now?
It is coming, sir. It is coming, sir.
Okay.
It is visible now.
So let me go ahead.
Yes, sir, please.
Thank you. Sorry for this inconvenience because of the poor bandwidth or whatever. So that's what the talk I wanted to make is about the innovations in the smart farming. And these are the tools and techniques which is available. I think IoT is one of the potential area where we need to work with. And keeping in view our Indian ecosystem, how it can be successful, that's what the challenge what we have. And making it more possible in the real time. And how we can connect to the small farm holdings and taking care of the socioeconomic conditions. That's what we are looking for. And when you look for the smart farming or any agriculture, it has the major key use remains is the variability and how best we can manage that variability. That's what the smart farming or precision farming we mean by. And those variabilities can be with respect to the soil, with respect to the crop, with respect to environment. And how those variabilities we can monitor and manage, then to enhance the productivity, that's what the challenge and that's what the research we are trying to do it. You can see the kind of variability what you have in the 4.16 hectare. That's what is captured using a sensor. And how best we can capture those variabilities starting from 4 hectare to 4,000 hectare in the larger scale, that's what the challenge. More the variability is captured, more the variability is observed, better potential is the smart farming. So how all these sensors can be used for that purpose, that's what the science we would like to look for. And there are different sensors on the ground and the unmanned vehicle, manned vehicle, and also satellite to capture parameters what we are looking at.
Mr. Sahu?
Yes.
Your voice is totally crappy. I mean, it's chopping in between and it's barely audible. I mean,
my goodness.
Yeah, it's breaking in between. Your slides are moving perfectly. So we are able to see your first slide and your presentation screen, but your audio is not coming good at all.
Now I am in the fourth slide now.
Yeah.
So my slide is moving, right?
No, your slide is also not moving. That's maybe you have shared only, you have to share your entire screen. But that is not a problem. The problem that can be sorted out, but the audio is not coming.
So what will be the solutions for this now? I don't know.
Maybe our people can try offline. In the meantime, there are some speakers waiting over here. Let's
tomorrow, then tomorrow I can come down sometime morning before.
Yeah, fine. We can do that. We can do that. That will be nice.
Not doing well and physically I was totally down by viral fever.
I know that. I know that, sir. That's so nice of you to have come on board on this despite your ill health. If you can come over here physically tomorrow, we will be obliged. Highly obliged.
Yeah, then we can connect each other and know the convenient time to come down there. I'll be
Yes, second half will be fine, but join us for lunch and maybe post lunch we can have that tomorrow.
We'll see.
And we can have a special session for you tomorrow physically. So for now, let me.
Thank you so much.
Thanks a lot for your cooperation, understanding, and we are looking forward to see you tomorrow.
Sorry for my side for inconvenience.
Never mind.
I know. Thank you.
Thank you. But we are looking forward to see you tomorrow.
Right, sir. Thank you.
Right. Thank you very much.
Yes, sir. December. किसमें 14 दिसंबर को डन होगा मैडम बताइए
ये
नहीं उसको दीजिए
So I would like to invite Dr. Kashdeep, Assistant Professor, Computer Science and Engineering from Punjab University, Chandigarh. He'll be delivering his talk on IoT and deep learning techniques for monitoring active fire locations and agriculture activities.
Thank you, and good evening all. Thanks to the organizers for giving a chance to be present among all the dignitaries and industry participants also. So I'll be taking up a talk on IoT and deep learning techniques for monitoring active fire locations and agriculture activities. So a few days back, this was the scenario in this NCR region. So whole of NCR was surrounded by smog, lots of clouds. This primarily was attributed to the fact that lots of stubble burning is there. In the states of Punjab, Haryana and UP, farmers burn the residue. And then because of the atmospheric conditions during the months of November and December, so the smoke gets trapped in the atmosphere, which creates lots of degradation of the pollution, and because of which a number of schools and other construction activities, they were closed. Right? So it's a common phenomena that has been occurring few years continuously, and just now governments have started taking some steps. So I'm here to tell you the story of So governments get serious few days back, right? And the story that I'm going to narrate you about what activities we did for tackling this sort of menace, right? And how IoT came into picture and helped us to design something to make a little contribution towards this challenge. So it all starts with the Department of Farmers and Agriculture Welfare, Haryana. So they approached the university campus to design a system for monitoring active fire locations, where active fire location is primarily the field area where stubble burning has been caused. Right? So it was a challenge because the farmers were actually, it's a security threat also in case a person visits a burning site. So they are kept hostages there by a group of farmers. So they wanted that we should design something which could help us cater to this challenge. The primarily target for them was actually the monitoring aspect. So they want to monitor that whatever information they are getting from, say, some space organizations, is there an actual farm fire that has taken place or not, right? So previously it was a task that they used to do like this one. So a farm fire was there, and there's a space research agency, HARSAC, right, which was associated with the Haryana government. They used to shoot mails to the farming Department of Farmers Welfare, right? And then from the mails, a person sitting at say at the office, they used to post emails to different employees. Employees means the field persons whose task or whose duty was to go to whose duty was to visit the farm and report whether a farm fire has occurred or not, right? So this was the whole system. And primarily this area that you see that was a bottleneck. HARSAC people, they actually were reluctant to reveal what sort of techniques or what sort of algorithms they are using for development of or for getting this information of exact location of farm fires, right? So this was the format in which they used to specify the information, right? A mail used to come, and this was the format, longitude and latitude, together with you can see the time at which that particular farm fire was captured, right? So what we proposed in the first place that let's propose a system for monitoring of farm fires, right? So what we did, we designed a web-based system and an app in which once a mail is received into their email, right, it automatically detects that email and shoots notifications to all the people who are involved in this process, right? It may be officers which are at the district level. It may be officers which are at, you can say, the field officers. They used to get notification into their apps. So it means the whole target of this process was that we want to reduce the response time. So the time of response time that was initially for a period of say 1 to 2 days, and now it's considerably reduced. So at about say in the evening, they used to get email, and after 4 to 5 minutes, the notifications were issued to all the employees that were involved in the process, right? So the particular system was designed with 4 types of users, right? And the process initially was that once ADO, that was the term that was associated with the employees, where it is the field officer. They used to get notification, and then it was its duty that he has to visit that particular website or particular place and report whether actual farm fire has taken place or not, right? And he was supposed to click pictures of that particular location, and after clicking pictures of that particular location, he used to upload that. It was all his duty to do such a thing. We also make sure that in case any citizen he is visiting alongside the road, right, he is also in a position to report these farm fires. So it was sort of crowdsourcing facility that we provided in the system. So all these are actually you can say the functionalities of the system that we proposed, right? So this was at the admin side. So all the locations that you're seeing in different colors, they are representing the number of farm fires we received into 2020. So because at that time we started with this one. So another challenge for us was how to make sure that the person who is on duty, right, he visits that particular place, right? So then we make sure that his report filing will be only enabled once he is physically present at the particular location. So only you see those 2 options, check-in and navigate. So check-in option will be only available once you are at that particular location, right? So this was about the first challenge. This was about the monitoring aspect of farm fires, right? Of course, web dashboard were also presented, in which different options were there for report generation and other facilities, right? Once this was done, there was the next challenge, right? Next challenge was how could we automate this whole process, because due to some reasons they involved with the space research organizations and Department of Farmers Welfare, they want that this whole process shall be automated, and can the system might be improved in some of the ways, right? So this was the first challenge. The second challenge was can this practice will be detected at the very basis one, means at the time when it's the farm fire is in progress, right? Because currently the system was such that we used to get all this information from the satellite data. So what we propose, let's go for IoT and AI sort of things, which could help us to design such a system. So this was the system that we proposed. Primarily, the whole monitoring system that was designed by us, right? 2 changes we did. First one is that it's visible on the top left, right? We just parted ways with the HRSEC, right? We explored what are the various areas from where HRSEC might be getting information. So we zeroed down to NASA. NASA has actually a platform with the name Firms, right? Where all the farms, all the fires across forest and farms, all are recorded. And they have satellites in place for that. So it's an automated system that provides you longitude and latitude of all those things, right? Then what we did, we wrote some scripts, right, which help us to decode data at the time it's available on the NASA website. So we decoded that data, right, and then converted it into a form which was good enough for Department of Farmers Welfare Haryana, right? So in that case, the response time, which was reduced from say 1 to 2 days to 2 hours, it was reduced to only 15 to 20 minutes, right? So whenever the information was available on NASA Farms website, we used to get that information and shoot off notifications to all the person involved in the process. Maybe it's the pollution board, maybe it's the agriculture development officers, maybe it's the district level officers, right? Next thing what we did, so this was all different kind of satellites we have. There are 3 kinds of satellites that were in place. MODIS, which has a spatial resolution of 1 kilometer. Right? It's you can say it's phasing out slowly and slowly. And then there is VIARS, which has two variants, one with the name SNPP and NOAA. So they are good enough with a spatial resolution of 375 meters. So it's a global standard that is being followed for the detection of fires. Right? Then we plotted all onto map, right, and get some locations, which was a combination of not 1 but 3 different kinds of satellites. Right. So these are the steps that we followed. First one is we used to get data from NASA forms, right? Then there are plenty of false cases because the satellites that NASA uses, it has, you can say, they're very sensitive, right? It can detect even farm fires going in a Havan also, as per the literature, right? So we need to remove those false cases, right? Then another thing that we did is there's a beautiful, you can say, or a very good system at Haryana. I don't know whether it's available in different other states also. They have a website known as jamamandi.nac.in, where all the land records of the farmers are there. Means if I'm owning any agricultural land, my land record is there in a digital form, right? That help us to identify 2 things. One is the village in which the fire has started, and we zero down to the place where or the field in which the fire has taken place. And next thing that could be worked out is what actually are the owners of that fields. So we combine or merge all these things and get to identify different locations and identify different farmers who are the owners of that land. Right. Of course, then report generation, send emails and call sequences, right? So these are some snapshots of the system that we designed. So downloading of files, then how we used to remove farm cases. We have something known as LULC maps of all the states. So it's again Indian space organizations, they provide you such kind of maps. Land use maps, right? So we zeroed down to the region of Haryana because we were working on the state of Haryana, and we just removed all the false cases, means all those boundaries which are falling outside the, you can say, territory of Haryana. We removed them, and then of course there were misreportings also. Misreporting also, say we are sitting in a city, Delhi. Say a location comes with the longitude latitude of this place. We used to discard that also. So such kind of information was combined, and then we zeroed down. These are the 5 locations that are available. Then we used to locate from the longitude and latitude where actually is the village, or what actually is the village that is reported by the longitude and latitude, right? Once that was done, we used to identify what kind of. So these are actual snapshot that you're seeing. So you could see. So Babu Ram, Putra Sahib Singh. See, these all are caught by combining all this information together. jamamandi.nac.in and all the information that we used to get from the satellites. Then we went one step further. Then there was, you can say, in-house device, which is a TEC certified, which is developed by our institute, right, with the name of Nesenzar. It actually helped us to initiate lots of calls. So all the farmers whose phone numbers are there with the department, right, we were in a capacity to make calls to those numbers, right? So without any operator, we could make any number of calls to all those farmers. So this is a snapshot that the system generates as an email to different, you can say, people involved in the process, maybe for the reporting issues, maybe for the record issues. Then, challenge number 2, how to make sure that we get the most real-time information. For that, what we proposed, we should design a system, or we should design a device which could be deployed in the fields, so that anytime a fire is detected, it triggers an alarm at the very instance, right? So this is the snapshot of the figure. So it has a camera, 3 sensors, right? And it used to have a deep learning algorithm. So the cameras, the input of the cameras, it continuously monitors a periphery or a vision range of the camera. It monitors all the activities that are happening in the presence of camera. And there's a deep learning. By deep learning, I mean there's a neural network that is running behind, which will trigger a notification or a confirmation whether a fire has started or not, right? And of course, the sensors that we normally use, it has a smoke sensor, humidity sensor, and a temperature sensor, which continuously transmits data, which will help us to see whether a fire has been generated or not, right? So this is you can say, circuitry diagram of a device. So we started with this sort of device in the beginning, in the cardboard, right? You could see some wires that were poking around, a camera at the top, right? And this is the device that we built. So not at the commercial stage, but at a lab stage, this device is available. And then how to test this device? It was again a challenge for us, where to test it. So we make an app for this one. And we lit some fires in the grounds of the university with permission, right? So that it shall not go. We used to do it in the night also. So this is the snapshot, which was an actually fire we used to burn in the campus, just to test how good our device is working. So got a message. I'll be concluding this. So all these are the screenshots, right? So the algorithm. Fine. What next? Next, we started with can we use or can we explore the satellite information with more details? So what we did, we used to get a satellite picture of a district. Say we involved Panipat district, and we tried whether we could zero down to different areas. Say there's a paddy crop, there's other kinds of crop that are being there. So can we do it with the help of deep learning algorithms as well as satellite data? So this study is in progress. And secondly, we are also trying to connect farmers, industry, and government at a single you can say interface, where farmers can rent out machines, farmer can buy machines directly from industry, or can avail subsidies from government agencies, right? That's it, sir. Thank you very much for patient hearing. Thank you for giving a chance.
Thank you, sir, for your presentation. I would now like to invite Mr. Arindam Bhattacharya to present a moment to the speaker. We have a next speaker, Professor Dharmendra Singh, IIT Roorkee. He'll be talking on standard-based deployment of applications in agriculture in Indian context. He'll be joining us virtually.
Oh, very good evening to all of you. Am I audible? Am I audible?
You're audible, sir. Quite audible.
Yes. So very good evening to all of you, and thanks for inviting me for delivering a lecture on such a wonderful topic. I am just going to share my slides. I think is it visible? Right.
It's visible, sir.
Yeah. Okay. Great. So just hide. Yes, so today I have myself Dharmendra Singh. I am professor in Department of Electronics and Communication Engineering. and I am a joint faculty in Department of Computer Science and Engineering also. So today I am going to discuss the deployment of IoT applications in agriculture, especially for the Indian context. So sorry, I was not able to join in the offline mode. So agriculture, I am not going to say the details. Everybody knows that what are the agriculture requirement and where we are. And the most important thing, I will discuss what are the problems the farmers are facing and how the technological advancement like IoT can solve the things, and what are the standards required, what are the things required from the scientists or from the policymakers, so life of the farmers and life of the other peoples can be more fruitful and more easyful. So you can see that just 1 minute. So you can see that the key solutions, whatever be the population increasing, developing country, India is developing country, largest producer in the major crops. So nowadays, one motto is there, the doubling the farmer's income. So once we are saying the doubling the farmer income, so how we can reduce the wastage, how we can efficient distribution, efficient crop management, demand of supply control, all these things, all the three components of the crop management we have to see for that one. So I will be discussing. So agriculture in India, we are knowing that crop seed research, monitoring, management, production estimation. Why I'm talking all about this? In all the aspects, we need the actual information, and there is a need of some IoT based sensor or something like that one. Existing agrarian situation, as we are knowing that acute labor and water scarcity, increasing input cost, fluctuation in market price, land fragmentation, increasing competition at a global level, young generation enter to the agriculture, leave agriculture. This is also one of the major challenges which we are seeing that. More demand, therefore more demand from the scientists for agro advisory. And who will do the agriculture for the next generation? There is a huge question mark for this one. So need to provide, so make, as I have mentioned, that to make the life much more easier, comfortable, provide instant expert agro advisory service, virtual agriculture practices, farm specific agro advisory. Till now, we are getting whatever be the information, it is not the farm level, it is the region level or the global level, and that is not very helpful for the farmers. So what kind of information required in a real time? You can see that soil, meteorological parameters, seed report, water related reports, insurance covers, other assets. During crop growth, this is the before sowing of a crop. During crop growth, crop type, phenology, health, stress, pre-harvest, crop health, post-harvest, yield, grain quality. So, and for that, we need the temperature, precipitation, humidity, cloud cover, sunshine, and number of things are there. We are working since last 20 years in this field. We have developed several products, but I am not going to show you the products. I am just going to discuss the challenges and in what way we have to come forward to reduce or minimize the challenges. Multimodal modern sensors for data collections. A lot of sensors are available either in airborne missions, IoT based, satellite data. So a number of database sensors people are trying in a different way. Different things are there, and then you can see that this is some different kind of images and different kind of information we are getting from the different sensors. Challenges, that is the most important thing, the challenges and vision. Data either not available, not accessible, or not reached to the right place at the right time. Speedy and reliability in the data processing. That is one of the very big bottleneck of any IoT based interpretation. A strong closed loop system between farmer, resource and authorities. So there is a need of the single point solution for which we are working. Any information, any inference system which can receive crop information via different this one. For this we are working, and we are saying, is it possible? So somehow up to a certain level it is possible. IoT, we are knowing that everybody is knowing that Internet of Things, relationship will be people to people, people to things, things to things, all the information in a one platform, and how we are capturing, how we are analyzing, how we are disseminating. That is the main purpose of the IoT. So you can see the structure of IoT, things, then the gateway. I will little bit discuss about, because this is a talk for the standardization, where the need of the standardization, what to do for that one, I will discuss in the later part of my presentation. And the services. Terminology, you can see that maximum information, whatever is the sensors. So IoT simply doesn't mean that the sensors, it may be the satellite-based sensor, it may be the ground-based sensor, it may be the airborne sensors. It is a data collection device. And especially for the agriculture, I will discuss what kind of, as I have mentioned, that what kind of data is required, and for what kind of data is required, and for particular data, what kind of sensors are required. General structure of the IoT. So because standardization, so we have to know that processing, application layer, network, information exchange layer, sensing, data acquisition layer. So you can see that this is the data acquisition layer. Solves issue like a data collection, information exchange. So IoT and communication between this one, and this is the application layer. Concept of IoT. So you can see that different comprise millions of network embedded devices and smart items, RFID, whatever be the things, whoever be that capable to work as a receiver to transmit the data and receive the information, or only the transmit the data. In both it is working that. Traditional, as we are knowing that, I already mentioned that traditional is a very cumbersome, but the IoT may give some relief to the, although it has a big challenge to place because it is giving the point information. So it is a big challenge to how to get all the things, but may give some relief to the farmers and the other planners, agri planners and agroeconomics and all other things. The structure and principle of IoT, you can see that data, information, knowledge and wisdom. I am not going to discuss detail. So this is the actual platform. You can see that this is the platform. Why I am talking that in my later part of this presentation, I will be discussing the data privacy, data security, data type of sensing network, what are the things are required. So these are the gateway, sensors, collector, gateway, and then the dissemination, exchange of information. Then the data center is there where we have all the analysis and all. And then the regulation, irrigation, storage, receivability, or whatever be the things that. So you can see that, as I have mentioned in the last slides, IoT transport layer, IoT perception layer, and the IoT application layer. So different sensors, how they are able to get the sensing information, and then how they are exchanging with the data network, and for what application, it depends upon the cleverness of the users or the scientists who are making it, how we can use it. Revolution, you can see that, as I have already mentioned, sensor layer, transmission layer, processing layer, alarm analysis, whatever be the control. This is the alarm analysis, means whatever be the threshold, if you are putting for the stress, crop stress, if you are putting for the soil stress, or if you are putting for any weather stress, you can make it. It is not a big deal for that one. Main components used in IoT. So this is the latter part of this one. Low power embedded system. Once we are deploying any sensor, that is one of the biggest challenge, how we provide the power to that sensor. That is the important thing. So low power embedded systems are required. And then backup is also a big challenge. How we are working something for that, but still it is on a very infant phase. Sensors, how sensors are, because you know that digital sensors are very viable and means giving a lot of error. So it should be the what sensitivity of the sensor, what kind of things are there, then the control in it. So major processing work to IoT device. Then goes to the cloud computing, that again the key where to put all the data, and then the network and connection. This is the last mile, how the end user is going to use it. IoT in agriculture. So you can see that the UAV farming, monitoring farm, precision farming, supply chain management, whatever be the things, whatever you think, all these things comes under this one. Applications, as I have mentioned that people are basically, as I have mentioned that for the cost cutting, wastage of lowering the wastage in one way. If you are going for the precision farming, we don't have to put the fertilizer for all the places. Only we have to put the fertilizer at the particular hot spots where it is required. This is one of the huge case for that. So that there we can reduce the cost and all. Agricultural drones, livestock monitoring, smart greenhouse, whatever with the thing. So as I have mentioned that devices in agriculture, that sensors that required weather conditions, temperature, humidity, wind, rain, light, motion sensors, soil moisture, air pollution, actuators, electric switches, because sometimes if you are irrigating the land, and once it is irrigated, so automatically it can be switched off. So electrical switches, electrical valves, RFID tags for communicating the data at the data center. Current state of the IoT deployment in Indian agriculture. So I have taken this from the April 2020-21 NASSCOM survey. Services shift India continue to dominate agrarian economy with the 16% agri to GDP ratio relative to the global 6.4. Pre-harvest, 90% of agri-tech startups are focusing on pre-harvest solution, but scale up will take approximately more than plus 5 years. 2% farmers use mobile apps for farm-related activities and real-time alerts. Post-harvest, 50% enterprises adopted proof of concept or proof of trials. 3x growth of IoT adoption in agriculture. It is very important for making a good work. Standards in deployment. So as I have mentioned that this is a very important IoT standardization. Spectrum is very important. With the spectrum, where we have energy communication protocol, standards for communication with the outside the cloud, international quality integrity standard for data creation, data traceability, energy consumption, safety standard. For example, device sensors are used for humans, and then the last, the privacy and the security standards. Challenges, as I have mentioned that this is the and IoT is still in agriculture in very infant stage. Robust connectivity is very important. Standardization, still we do not have made any standardization. So we have, as I have shown in our third or fourth slide, what are the data required for agriculture. So what kind of sensitivity for all three layers we need the standardization, not only the communication layer. All three layers means the sensing layer, perception layers, and application layer. All three layers we need the standardization. I can discuss much more for this. We are working little bit about this technological sustainability, interpretability, slow deployment, security of IoT device. This is again, if you are putting in the field, then how to secure it. So you can see that the technical and the policy, data localization, open data, legacy, cross-border traffic, governance, whatever be the things, a lot of things are there. Standardization at global level. So there are several agencies, ITU, ISO, IEC, M2M, 3GP, and ITU and T study group. This is the SG20 group. They are trying to make some applications for smart cities and communication and trying to develop some standardization. ISO, IEC Joint Technical Committee created subcommittee of IoT for the digital twins. M2M, now we are talking about the 5G and 6G. That is very important for this. And for India, TSDSI is the, so this is working on. And once we are talking, so IoT, ICT enabled in the smart village and agriculture. So we need Wi-Fi hotspots, low power, wide area network, and all other things. I will show you code of practice for securing consumer IoT. So that is the part once we will use what are the security measures we have to take care, and everybody means we have to educate the people. You can see this is the very important. Once we are going for the middle layer, communication layer, so what kind of things we are required? Short range, wireless local area network, wireless neighborhood area network, wireless this one. So all these has the range. Different devices are there, and how we can use it. And again, very important thing, not only use, how to sustain it. That is a very important. In agriculture, so we are talking, people are talking IoT adoption index. For this one, it is a composite weight scores across awareness, uses, benefits, and time to scale deployment. So this is the performance analysis for any IoT-based application in agriculture. So IoT adoption index, track various IoT technologies, their deployment. So we are knowing that this is the pre-harvest stage, tilling, seeding, irrigation, fertilizer, harvest monitoring, post-harvesting, agri-warehousing, agri-processing, agri-supply chain, and IoT application index, components and weights. You can see that the awareness 10% weightage, usage 40%, benefits 30%. So all these are this IoT adoption index. This gives the performance indication how we are doing that one. IoT adoption in Indian agriculture. So I have taken from that NASCOM report between 27 to 30%, 37% IoT adoption is significantly low. Awareness and use of IoT solution in pre-harvest stage is very, very limited. Post-harvest agri-warehousing is also limited. Pre-harvest benefit, connected agriculture planning and architecture is needed. So these are the some bottlenecks, or these are the some places where we have to work. So different information taken from the different way, and we are working for solving the different challenges. And thank you very much for providing the time for this. Okay, thank you very much. If you have any question, I will be happy to answer them. Any question?
No, sir.
Okay.
Thank you, sir, for your presentation. I would now request Mr. Manish Saxena, Director NT-DOT, to provide the concluding remarks of the session.
Thank you very much for giving me this opportunity to give the concluding remarks for this session, which is the third technical session of the day, based on IoT M2M applications for agriculture. We had very eminent speakers from India as well as from abroad. Mr. Gustavo from CPQD Brazil has highlighted the IoT-based agri-tech challenges and solutions in Brazilian context. We had Dr. Akashdeep, Assistant Professor, CSE UIET, Punjab University, Chandigarh, who has highlighted and he has shared his the real life, basically a real life case of stubble burning and its smart solution. And then Professor Dharmendra Singh from IIT Roorkee, who has given a overview of standard-based deployment of applications in agriculture in Indian context. Because of some technical glitches, we could not hear Dr. Rabi N. Sahu from Indian Agriculture Research Institute. Most probably he would be joining tomorrow for this for his lecture. So I thank all the eminent speakers and all the participants. And I thank on behalf of DOT, TSDSI and CDOT for giving for this wonderful session and this 2-day conference on IoT and M2M applications in India. Thank you very much.
Thank you, sir, for providing the concluding remarks of the session. I would now invite Mr. Arindam Bhattacharya, Group Lead CDOT, to provide a momentum to the speaker. Thank you, everyone. With this, we'll break for tea and conclude this session for today.
Tomorrow, starting at 9:30, session is Smart City. Transforming cities. Eminent speakers will be there.
So it's requested for everyone to join at sharp 9:30 tomorrow. Thank you.